Hi everyone, welcome to Vedantu JEE English. I'm Diksha Kaushal, your chemistry master teacher. And students, today we are going to do alcohol, phenols and ethers part 2. So in this part, we are going to talk about phenols and ethers, and we are going to do previous year questions from this chapter as well as some twisted, interesting questions, right? As you all were asking them that we want to do more of questions. So I have brought up so many questions for you so that we can practice in this lecture itself. Okay guys, so everybody in the chat box, a very good evening, very good evening. So I hope so you all are just amazing and you all are doing your preparation really well, and always I am always here for you. So those students who want to talk to me, right, they can always subscribe to my channel, that is Diksha Kaushal Chemistry Official, and also talk to me on Vedantu JEE English. You can write your queries in the comment section, or you can write down your queries in the Telegram comment section, right? I will definitely reply you all. Okay guys, so everybody with a beautiful smile on your face, let us start the session. And last time we did alcohols, right? So it was a big chapter, it was a big chunk of this chapter, right? Today we are going to focus on phenols, and from this also direct questions are asked, right? Direct questions, right? And after that, a very small part, that is ethers, right? Some of the reactions in ethers are direct predictable questions, right? I'll also show you how in NEET 2024 questions from ethers, phenols are directly asked, right? Okay, yes, okay, yes everybody. Chal. Now let us start with the preparation of phenols. Okay, so starting with the preparation of phenols, this is, first thing is, acha, what is phenol? What is a phenol? Ma'am, phenol is nothing but when you have a benzene ring, over it when we talk about there is one OH group, that is called the phenol. Now how can we make phenol out of different things? So the first and very important process is Dawes process, right? And this Dawes process mainly talks about the conversion of chlorobenzene, this is chlorobenzene, to phenol. Chlorobenzene to phenol. It mainly talks about chlorobenzene to phenol, right? So we did one reaction in haloalkanes and haloarenes, that if you want to convert this thing, for example, if I am saying that you have RCl, you want to convert it into ROH, right? I told you if you want to substitute chlorine with OH, if you want to replace that, what you have to do? Just give it some base like KOH or NaH and aqueous, right? This Cl will be replaced by the OH. So ma'am, we can do the same thing here. Ma'am, you can add NaOH or KOH. I am adding here NaOH, right, in aqueous, and ma'am, this reaction will occur, right? This is the first thing that will come in your mind. But here I am saying it's not possible just by adding NaOH aqueous, right? You also have to give it a high pressure and high temperature. Only then it is possible. Because of that high pressure and high temperature is 300 degrees Celsius, high pressure is around 200 atmospheric. Because of this high pressure and high temperature, this has been converted to Cl to OH, right? This has been converted from Cl to OH. Understood? Now, because of this high temperature, high pressure, it is called a Dawes process. We have given it a specific name. Now, next thing is, ma'am, why this reaction cannot occur just by adding NaOH aqueous? Why we have to make high pressure, high temperature? What is the reason behind that? So, the reason is, now tell me one thing, you have two things here, right? So, here I have, when I talk about Cl, you have this thing, right? Now, we know that chlorine has lone pairs of electrons. Because of this, what it will show? Because of this, it is going to donate the electrons to the ring, right? So it is going to show plus M effect. It is going to donate the electrons into the ring, and you will have the resonating structures as this is negative, this is double bond, this is Cl, this is positive, because it is giving out the electrons, so there will be one positive. Again, it is what it is doing, again the electrons are getting jumped here, right? And again you will have this thing, again you will have this thing. This is double bond, this is negative, double bond, Cl, and this is positive, right? Now again what will happen? These electrons are going to jump here, this double bond is going to jump here, and it will form double bond. This is double bond, this is negative, this is double bond, Cl, positive, right? So these are the resonating structures of chlorobenzene, and in the end this electron is going to jump here, the double bond is going to jump here, and hence you will have the last structure as this is Cl, this is double bond and double bond, right? Because of these resonating structures, what you can see before, if you only see this compound chlorobenzene, you'll see, ma'am, C, carbon and Cl, these two will have a single bond, right? But as you can see in the resonating, very good, this is ortho-para directing, very good, because it is having negative charge on the ortho and para position. So towards electrophilic substitution reaction, it is ortho-para directing, right? Now because of these double bonds here, right, it has partial double bond character, right? So it will have partial double bond character, partial double bond character. Now ma'am, why you are telling us why this partial double bond character? Guys, because if you want to break some bond, right, if for example you are shaking hands with the other person just by this one hand, right, so now your bond is weak, right? If you are shaking hands like this, okay, hands like this, now the bond is more strong. So if it has a double bond character, that means the CCl bond is stronger as compared to a situation of a CH3Cl where there is no double bond character, and because of this CCl bond is weaker and this CCl bond is stronger. That is why it is difficult to break this bond, right? That is why we have to give it high pressure, high temperature we have to give it, right? The next thing is, now if I am saying that, if I want to talk about in the form of sp3 sp2 hybridization, so as you can see this, here it is Cl and here it is CH3 and this is Cl, right? As you can see here, in this carbon, how many sigma bonds it has? It has 3 sigma bonds. 1, 2, 3. 3 sigma bonds it has. That is why here it is sp2 hybridized. But this carbon atom, it has how many sigma bonds? 1, 2, 3, 4. That is why it is sp3 hybridized. Now we know that the electronegativity is in sync with the S character, right? More is the S character, more is the electronegativity. So electronegativity order is, maximum is for sp, then you have sp2, minimum is for sp3, right? That means for sp2 electronegativity is greater than sp3. That means the electron hold is greater in this situation as compared to this situation, right? That is why it is easy to break this bond as compared to this bond, right? That is the second reason that why CCl bond is difficult to break, right? Now, third is, if I am successful, I'm like, by hook or crook, I will break this bond, right? Now, after breaking this bond, what I will have? I will have this phenyl cation, right? I will have this phenyl cation. And this phenyl cation is a very unstable species. It is not a stable species. It is a very, very unstable species. Because of this unstable species, phenyl cation, right? It is difficult to break this bond, right? That is why we need high temperature, high pressure, and it is going to follow this Dow's process, in which you will not have the formation of this phenyl cation as the intermediate. Rather, the intermediate will be this one. This is the intermediate, right? The intermediate will be, wait a minute, the intermediate will be benzyne, okay? That is going to be your intermediate, This is going to be the intermediate of Dow's process, right? That is going to be the intermediate of Dow's process. Now, we have talked everything about why we need Dow's process. What was the requirement? So now let us see the full reaction here. You have chlorobenzene. From that chlorobenzene, because it was difficult to break this bond, that is why we needed high temperature and high pressure, right, in presence of NaOH aqueous, right, and you have the formation of this benzene ONA. Wait a minute, this aqueous they have not written here, right, because this is the first step they have told you. That firstly what will happen, you will have the formation of phenoxide, sodium phenoxide. What is this? This is sodium phenoxide. You will have the formation of sodium phenoxide when you will add NaOH and high pressure, high temperature. Then after adding HCl, this Na will be replaced by OH, and hence you will have the formation of phenol. Right? So that is the first thing. Now, second thing about Dow's process, very, very important. This question also can be asked to you easily, right? Now, they will give you one situation. For example, they are saying that you have this OH, you have this Cl, right? But you have at ortho position, you have one NO2 group. Then again, you have this chlorobenzene. Now, at 2 ortho position, you have NO2 group, right? Again, you have one chlorobenzene. Now, you have NO2 at 3 positions, that is ortho and para, right? Now, in these cases, what will happen? This is A, this is B, this is C. Rate of reaction will be highest in what? Now, see, if you talk about the rate of reaction, ma'am, here we can see that what we are doing basically, we are adding this NO2, this NO2, this NO2, this NO2, this NO2, right? Okay, and they are asking you the rate of reaction. To make it more interesting, I'll also do one thing. I'll also make one more compound here, right? That is your D compound, and that is going to be when you have NO2 group at the meta position. Now you have NO2 group at meta position. This is the meta position, right? This is the meta position. They are asking you what will be the rate of this reaction. So any idea on this? Any idea on this, guys? Any idea on this? What will be the rate of reaction? Any idea on this? If yes, then I would love to know your answers. Now what we can see, very good, Dhanu, very good, Dhanu. You know what, my niece name is also Dhanu. So yeah, very good, Kareem, Afsal, Saima, Kareem, then Pradesh, Rishi, Anirudh, Anandu, Bhargavam. Yes, A, B, D, C. Now let us see what will happen here. Now remember, at ortho and para position, what I told you. At ortho and para position, when we were drawing the structures here, the resonating structures here, this is the ortho position, this is the ortho position. This was the ortho position, this was the para position, and this is the ortho position. That means at ortho and para position, you have a negative charge. So, for example, you have added one NO2 group, you have attached one NO2 group, that is electron withdrawing group, right, at the ortho and para position. So, what will happen? That negative charge, Rajesh, I am not ignoring you. So, that negative charge, it can pull, right, this electron withdrawing group, that is taking out the electrons, it is going to pull out those electrons at the ortho and para position, right? But at meta position, there is no electron, there is no negative charge at meta position. That is why there is no use of adding electron withdrawing group at the meta position. Now, ma'am, if electron withdrawing group is subtracting, it is taking out the negative charge, the rate of reaction will increase or decrease, right? So when it takes out the negative charge, what will happen? It will take out the negative charge from this side, and more will be this positive charge will increase, right? That is the reason the rate of reaction is going to increase here. So electron withdrawing group is going to decrease the electron density here, which will make this CCl bond a little weak, right? This CCl bond will become little weak because the electrons, for example, I am taking out this position. If I attach one electron withdrawing group here, it is taking out electrons from here. That is why it is pulling out electrons from here, and hence this CCl bond is getting weak and weak and weak. That is why there is use of attaching electron withdrawing group at ortho and para position. More the electron withdrawing group, more is the rate of reaction even when the temperature is not very high, right? Okay, so yes, here we need drastic conditions. But if you have added at ortho position, you have added one NO2 group, the temperature will decrease, right? The pressure will decrease. You need less temperature and less pressure. If you have attached two ortho groups, you need less temperature, right? And less pressure. Now, if you have attached 3 NO2 group, maybe you will just warm it, right? Nothing else, you will just warm that mixture and you will have the formation of picric acid, right? Because it will be OH here, rest of the things will stay as it is, right? I will draw this on the next page only. For example, you have Cl, you have Cl, you have NO2, you have NO2 at ortho and para position. Because at ortho and para position, it is going to increase the rate of reaction. Even if you just warm this, you are just warming this, you just warm this mixture, right? What will happen? This will get converted to, this will get converted to, this will get converted to, this is OH, this is NO2, this is NO2, and this is NO2, right? And this is NO2. That is going to be the correct answer here, right? Is that clear to everybody? You just need to warm it in the presence of NaOH aqueous. That's it, right? No need of high pressure, high temperature. And what is the name of this thing? If anybody in the chat box, what is the name of this thing? Yes, what is the name of, ma'am, please do PYQs, ma'am. Yes, Darshan, definitely I am going to take up PYQs, right? See here, you have the PYQs, right? Here you have the PYQs, right? These are all the PYQs that I have taken up for you, so don't worry about that, right? Now, wait a minute. Yes, it was this thing, right? So, what was the name? The name is picric acid. The name is picric acid, right? That is also yellow in color and this is called picric acid, right? Now, coming back to the question that I asked you, that the rate of reaction and at meta position, there is no change in the rate of the reaction. So it will be very slow. It is very, very slow. The rate of the reaction is as it is. It needs high temperature, high pressure to get converted to replace the Cl2OH, right? But if I talk about these three situations, more is the electron withdrawing group, more is the rate of reaction. The rate of reaction is maximum in B, right? Then you have, not in B, yes, in C, maximum in C, then you have B, and here you have A. So answer will become, if you talk about the increasing order, answer will become D, A, B, C. That is your rate of reaction. That is your rate of reaction. Understood? That becomes your rate of reaction, right? Study alcohol phenols without GOC. Okay, Pradeep, do one thing. Yes. See one thing. Don't worry, I'll teach you GOC. Don't worry about that. We will see that in the end. Yes, right now I'll tell you it's not possible to study organic chemistry without GOC. But if you have not done GOC like completely in a good manner. So don't worry about that. I will teach you GOC. Just right now follow what I am saying, right? Okay, because the concepts of GOC I will tell you in between, but yes, I will give you specific dedicated lecture on GOC as well, right? Okay, but if you have already completed that, then I will advise you to go through and revise that before doing alcohol, phenols and ethers. But it's not like you won't be able to understand only, but yes, when you're solving the question, the concepts are very important, right? Okay, yes. Now next is Cumene process. Again, a very important process, Cumene process. For Cumene process, you need to understand what exactly is this Cumene. Cumene is nothing but it is isopropyl benzene. That means you have this benzene. On this benzene, you have isopropyl group like this. You have isopropyl group like this. This is your Cumene. This is called Cumene. So here, what we will do, we will add oxygen, right? Okay, and then we will convert this Cumene into phenol and acetone. Let us see what we are going to do. A very important reaction. This is your benzene. Firstly, benzene is converted into Cumene by different processes. Here, one of the processes, there are you can do a lot of processes by which you can convert benzene to Cumene. First is, if you are adding an alkene and H positive, right? Alkene and H positive means this bond, it is going to break, right? Because now whenever there is some double bond is going to break, what will happen, right? Either electrons can jump this side or electrons can jump this side. Two possibilities. Either electrons will jump this side or electrons will jump this side. I am saying the electrons are jumping this side, so it will be negative, here it will be positive. Again, I am saying the electrons are jumping this side, it will be CH3, CH2, this is negative and this is positive. There are two possibilities. Now students, tell me, to a negative, you will have the attachment of H positive, so it will become H2. To this negative, you will have the attachment of H positive and hence it will become CH3. Now tell me which is more stable. Is this more stable or this more stable? If I talk about this is A, this is B, which is going to be more stable? Which is going to be more stable? Arey ma'am, this is going to be more stable because it is giving us one. This is where GOC is going to work, right? So this is one alkyl, this is another alkyl. It is going to give you donation effect from two alkyl groups. So I told you, for in case of carbocation, think it as money. If you are under stress, you are not under stress, if you don't have money, you are poor, then what do you want? You want someone to give you money so that you can get stable. Here only one person is giving money, right? Here two people are giving money. That is why this is not accepted, rather this is accepted, right? Okay, or you can think that definitely this carbocation is 2 degree and this carbocation is 1 degree. So 2 degree is more stable than 1 degree carbocation, and that is the reason this is not preferred, but this is preferred. That is why what you will have this benzene ring here, and hence you will have the addition of this CH3, CH positive, CH3, it will attack here, and hence you will have the formation of CH3 and CH3, right? This is what you have Cumene. That is just the first process, right? Because we are talking about not an easy exam, right? So we have to get into deep knowledge of this, right? So it's not like they will ask you only this process of making Cumene, right? They can also ask you other question, right? They can give you, this is benzene. You have CH3, CH2, CH2, Cl, and you have anhydrous AlCl3, right? What will be the formation here? What will be the answer here? Anybody in the chat box? Anybody in the chat box? Definitely, ma'am, if you are giving it here, then definitely it is going to be Cumene only, but how? Let us see. We know that, tell me, what is this reaction? Yes, what is this reaction? This reaction is Friedel-Crafts alkylation, right? Friedel-Crafts Friedel-Crafts alkylation. Okay. Friedel-Crafts alkylation. Here you will have the formation of this kind of carbocation, that is CH3, CH2, CH2 positive, because this bond, it will break, electrons will jump here. Then because it is a 1 degree carbocation, it will rearrange itself to a 2 degree carbocation, because definitely 2 degree is more stable. So you'll have the formation of this thing, and hence after that you will have the formation of, I'm writing it directly here, you will have the formation of this cumene. Oops. You will have the formation of this cumene. I am directly writing it here. Right? Okay. You will have the formation of this cumene. Okay. Understood? Simple. Right? This is how organic chemistry is linked to each other. Right? Okay? Yes. Very good. Now, next thing is, this is a full-fledged reaction. Once you have the formation of cumene, right, then what you give it? Give it air, right, in presence of air. This bond, that is CH, it will have a peroxide linkage of OOH, right? That is why the here answer is cumene hydroperoxide, because you have a peroxide linkage of OO, right? That is the peroxide linkage. So once you have this thing, after adding water in acidic medium, what you will have? You will have the formation of, from here you will have the formation of acetone, and this OH will be linked here. So you will have the formation of phenol, right? The mechanism is not in your syllabus for this step, right? So just remember that from here you will have the formation of phenol and acetone. Here the byproduct is also important for you, right? Here the byproduct is also important for you, that in the cumene process you have phenol plus acetone, two things, right? Okay. Now, next is third step. Third step is alkali fusion of sulfonate. So this is not like that much asked. First two processes are very important, Dow's process and cumene process. Frequently asked questions, right? This is not so important, right? But yes, you should go through this, right? Sodium salt of benzene sulfonic acid is fused with sodium hydroxide. What is sodium salt? That is your benzene. First, with the oleum or H2SO4 fuming, you will have the formation of benzene sulfonic acid, right? That means this is the reaction that you did in hydrocarbons, right? In hydrocarbons, you did this reaction, right? You remember? Now, in hydrocarbons, we have done this reaction. After that, if you add NaOH into this, here they have directly written that you add NaOH. If you add NaOH, you fuse it with NaOH after that, then you will have the formation of, after NaOH fusion, you will have the formation of ONa. So basically two things we are doing here. Firstly, we are adding NaOH just like that, right? You will have the formation of, instead of this, H will be replaced by Na, right? This H positive will be replaced by Na. But if you want to convert this SO3Na to ONa, then you have to, wait a minute. Yes. Then you have to fuse it with NaOH, right? If you are converting this directly, if you are adding NaOH directly, then this H positive is replaced by Na, right? But if you want to convert this SO3Na to ONa, then you have to fuse it with NaOH, right? Fusion, you know, NaOH, how it is fused, that is different practical process, right? So it is fused with NaOH, then this SO3Na is converted to ONa. Once you have sodium phenoxide, then you just add H positive from anywhere, right? Then it will be added and you will have the formation of phenol here, right? And hence you will have the formation of phenol here, right? Okay, that was the third process. Fourth is from Diazonium salt. Now for this you need to understand what is basically a Diazonium salt. Yes. Have you marked your attendance for Diksha ma'am? Let us see how many of you have marked your attendance. Let us see. 25% of you have not marked it yet. That's sad. In the first lecture, you guys were so excited, but now where is the energy? Where is the Josh, guys? Where is your energy? Where is your Josh? Right? We have to be very determined. We have to be like in full energy every day when I am here so that we can complete. I just don't want to complete the rest of the syllabus. I also want a very good revision for you. I also want to conduct sessions where we can do dedicatedly, we can do previous year questions, we can do reagents, we can do so many things here, right? Specific dedicated lectures after completing your syllabus, right? But for that, I would love to see your energies in the comment section, in the sharing of the lectures, or in the chat box, right? Okay, yes. So guys, here we have from Diazonium salt. So now if you talk about Diazonium salt, what exactly is Diazonium salt, right? What exactly is Diazonium salt? Let us see that. Diazonium salt is basically diazo. You know what is diazo? Azo means nitrogen, right? Azo means nitrogen. Azo is a word for nitrogen. It's not a very different word. It's a word for N2, right? So this means diazonium salt. Now basically what is a diazonium salt? This is a diazonium salt, N2Cl. Diazo is for nitrogen, right? This is sodium salt, right? Basically sodium salt I am saying. This is diazonium salt of chloride here. This is basically N2 positive and this is Cl negative. Now this diazonium salt is not very stable, right? It is slightly stable that we can have different reactions from there. We have also done two reactions in haloalkanes and haloarenes. You must have done those two reactions, that is Sandmeyer's and Getterman, right? Where you used to make chlorobenzene from there, right? From diazonium salt. Now, next thing is, ma'am, how in other chapters it will be used? In amines, diazonium salt is very useful because we can convert this diazonium salt directly to aniline. So basically, we will study about this diazonium salt in detail in the next chapter, in next to next chapter, that is amines, right? But in this chapter, you have one reaction of diazonium salt, that is the conversion of diazonium salt to phenol. How you are going to do that? So let us see that, okay? That is the conversion of diazonium salt to aniline. Now, yeah, so this is your diazonium salt, benzene diazonium chloride, right? So this diazonium salt, very important, when you add water and just warm it, this is converted to phenol, right? Similarly, for example, you have some CH3N2Cl. Here also, if you want to convert it into CH3OH, it will be firstly, so this is very unstable. The diazonium salt of a compound which is directly linked to a allylic chain, that is, this is not allylic, alkylic chain, that is very unstable, right? This is actually very unstable. So it will directly give us alcohol. In case of when N2Cl is attached to a alkylic compound like CH3Cl, CH3CH2, a simple open chain, right? A non-aromatic thing. But if it is connected to an aromatic chain, right, like benzene ring, then it is slightly stable. That means still if you want to convert it into, if you want to replace this N2Cl to OH, you will have to warm it. You will have to add H2O. Only then you will have the liberation of N2 and HC. This is a very important question, okay? That when you have aliphatic compounds, aliphatic diazonium chloride, in that case, without adding H2O and warming it, it will directly give you alcohol. But if you are saying that you have benzene diazonium chloride, here you need to warm it and add water, then this N2Cl will be converted to OH, right? That means this is also unstable, this is also unstable. But this benzene diazonium chloride is slightly more stable as compared to any aliphatic diazonium chloride. Okay, understood? It's a very important question, right? Okay, now here the next question is, it should be like this, the arrow should be opposite, right? The arrow should be opposite, right? So here it's a very, very important reaction where we are converting, right? This is a reaction that we will do in amines chapter. Here what we are doing, we are converting this diazonium salt, right, to aniline, right, by adding NaNO2HCl, or you can just say by adding HNO2. Because this NaNO2 and HCl is going to give you HNO2 only, right? And here the temperature should be 0 to 5 degrees Celsius, right? That is also important for you. The temperature, the conditions, the reagents, everything is important, right? Because either so they will give you NaNO2 and HCl, but when they will react together, they will form NaCl plus HNO2, right? So basically this HNO2 has the total work which will convert this diazonium salt to aniline, right? Okay. Next important thing is from decarboxylation. Decarboxylation, soda lime decarboxylation. Right now, what is this soda lime? Okay, tell me, this is basically a 9th class you used to do this. What is caustic soda? What is caustic soda? NaOH is caustic soda, right? What is caustic soda? NaOH is caustic soda. What is quicklime? What is quicklime? CaO is quicklime. So from this they have made this thing that soda lime decarboxylation, right? Because we are using NaOH, we are using CaO. Both of the things we are using here in soda lime decarboxylation. But in soda lime decarboxylation, we have done this in hydrocarbons as well. I hope so that you have done that, right? But if you have not done that, I will teach you again. Now, what exactly is soda lime decarboxylation? In soda lime decarboxylation, for example, you have RCOO, Na, right? You are adding NaOH and you are adding CaO. What will happen? It will get converted to RH plus this is Na2CO, Na2, wait a minute, Na2CO3, right? Okay, it will get converted to Na2CO3. That means this carbon dioxide is going to liberate from here. That is why it is called a decarboxylation. That is why it is called decarboxylation. Okay, that is why it is called decarboxylation, right? Okay, guys. Now, what will happen in this case? If you want to make phenol from here with the help of soda lime decarboxylation, right? Ma'am, English alone, I think I am speaking only English. My English, I think that's the same way we speak English, isn't it? Am I speaking Hindi or what? In my school, they have taught me English like this only, guys. I don't speak foreign language English. I don't speak British English or American English. Okay. Now, this is the reactant. I told you that the rest of the part, this will be liberated out, right? When you add NaOH and CO2, that is soda lime decarboxylation, and you will be left with this compound that is called your phenol, right? That is how you have the formation of phenol, and here you have Na2CO3, right? That is called the fourth step. Now, next is, now let us do the properties, okay? So that was about the preparation of phenol. Okay, guys, that was about the preparation of phenols. Is that clear? Okay, so now here we have reaction of phenols. Now we are going to focus on the properties of phenols, right? Very simple. First property is the acidic nature of phenol. So if you talk about the acidic nature of phenol, if you talk about this thing here, right, this thing here, if I say I want to know the acidic nature of phenol, that means we are talking about after losing this H positive, it will become O negative. Then as I told you, a good acid is that thing that after donating H positive, how much stable carbon ion it is forming. So we have to see the stability of this compound, right? We have to see the stability of this compound, that is called phenoxide ion, right? So let us see the stability of phenoxide ion, right? Let us see the stability of phenoxide ion, right? This is phenoxide ion. We have to see whether it is stable or not, right? As we can say, this is negative. It will donate the electron here, and the electrons are going to jump here, right? Hence, you will have the formation of this negative, this double bond, and this is double bond O. Then this electron will be jumped here, and this double bond will jump here, and hence you will have the formation of a negative over here, and the negative charge is getting converted to a double bond, right? Here already you have a double bond, and here you have a double bond O, right? Next is this electron, this negative charge is converted to a double bond. This double bond is converted to a negative charge, and then you have the formation of, just give me a second, you have the formation of this double bond here, this double bond here, this negative charge here, double bond O, right? Again, this negative charge is converted here, this double bond is shifted to a negative charge, and hence you have the formation of, this is double bond, and this is O negative. Now, can you see this whole thing? See this whole thing? Basically, this phenoxide ion is under resonance. So, resonance will provide stability to that ion. That means, because of so many resonating structure, this phenoxide ion is very stable. Because this phenoxide ion is very, very stable, that is why this phenol is a very good acid. This phenol is a very good acid. It is acidic in nature, right? Okay. Yes. Ether I will teach in this lecture itself. Students, the name of this channel is Vedantu JEE English, right? Okay. If it would have been English, I would have definitely taught you in Hindi plus English. I know Hindi as well, right? But here the name of this channel is dedicated to that audience, right, who want to learn in English, who are comfortable in English, right? And I would really advise you that you should learn in English, because your paper is going to be in English, right? So it will be easy for you to understand the question, right? Okay. Yes. Now, here this is basically a good acid, because this phenoxide ion, this is very, very stable ion because of the resonance. Understood? Yes. Simple, right? Okay. Yes. Okay. Hi, Sanat. Hello. Yes. Now, reaction of the phenol. Now, the next thing is reaction of the phenol. First was its acidic nature. We know that it is good acid, right? Now, there are different reaction of phenols because of its OH group, right? Now, let us see. If you add NaOH into it, if you add a base into it, now tell me, I am saying this is acidic in nature. This is basic in nature. An acid and a base, right? When they react together, they will form a salt and water because of the neutralization reaction. Isn't it the neutralization reaction? Here what is happening? This is phenol. This phenol, because of the acidic nature, it is going to give off this H positive ion here, right? And this is NaOH. It is going to give you Na positive and OH negative. This is going to give you H positive and PHO negative. And this PHO negative is going to take this Na positive and it will become PHONa, that is sodium phenoxide. Basically, it's like this. This is your phenol. This is ONa, right? This is a salt and this is water. Basically, it is a neutralization reaction, right? Now, next thing is when you have pH, or that is phenol with Na. Now, any acid with a metal, when it reacts with the metal, it will give off hydrogen gas and salt. These are the general reactions that we used to do in earlier classes. In I think 9th or 10th, you must have done when an acid and a base reacts. they give you a salt and water. When acid reacts with any metal, it will give you hydrogen gas and the corresponding salt. So this Na positive is going to replace H positive. Here you will have the formation of a salt, that is phenoxide ion, sodium phenoxide, and this hydrogen gas will be liberated here, right? Then these are basically telling you that phenol is acidic in nature, right? Then you have NaH. Now again, what will happen? This is NaH, that means this is your Na positive, this is H negative, because here hydrogen is more electronegative as compared to any metal. That is why hydrogen has a partial negative charge. So it will give us H negative hydride and Na positive. This Na positive is going to replace this H positive, right? This will become PHO Na, right? And this H negative and H positive, they will combine together to give us hydrogen gas, right? Next is when it reacts with a very, very important, that is NaNH2. With this also it will give us Na positive, NH2 negative. Now this is going to give us PHO negative, this is positive. Now always do positive, negative, positive, negative, positive, negative. The same way we are doing positive, negative here. This positive is getting attached to this negative, right? Here it will become NH2H, it will become NH3, right? And this is going to become PHO Na, it will become PHO Na. Always do this, right? This is positive, this is negative, this is positive, negative, positive, negative. Here it is only metal, right? So these are the reactions that are telling you that phenol is actually acidic in nature. We have seen this by two methods, that the phenoxide ion is stable, that is why it is good acid, and the examples are these cases where it is behaving just like the way an acid will behave. Right, so it is definitely acidic in nature, right? Phenoxide ion is more stable, this we have already seen. Next is acidity of phenol, how it is going to increase or decrease, right? Okay guys, for that I will tell you one thing about the acidity, right? Okay, about this is from GUC, okay? Just to recap that thing here. Now see students, very simple trick I will tell you. Any group attached to a benzene ring, there is another group that is attached, right? Always remember one thing, if the group that is attached to the benzene ring is having some lone pairs here, then it is always and always going to show plus M effect. It is going to donate the electrons in the benzene ring. It is going to show the plus M effect, that is plus resonance or plus mesomeric effect, right? Okay. Now, whenever you have plus M effect, you will have ortho-para directing. Reason being, because here you will have partially negative charge on the ortho and para positions, that is why it is ortho-para directing towards electrophilic substitution reactions, right? Next is, for example, this group is attached to, this group does not have any lone pairs, but this group that you have attached directly to the benzene ring is further attached to a group, or you can say a atom, that is X, but the condition is X is more electronegative as compared to G. Right, X is more electronegative as compared to G. Now this is always going to show minus M effect, and that is always going to be meta directing. Reason being because you will have, because it is going to take out the electrons from this side, that because this is more electronegative, no? Because this is more electronegative, it is going to take out electron from this pi bond. It is going to take out electron from this pi bond, right? It is going to take out electron from this pi bond. Wait a minute. It will be like this. Okay. Here the electrons will jump here, but here the pi bond, it is going to, this group is going to take out the electrons. So that is why it is minus electron withdrawing. It is electron donating, right? Because of this, you will have a partial positive charge on the ortho and meta position. That is why towards the electrophilic substitution reaction, it is meta directing, because the electron density on the meta position is more, right? Okay. Understood? Now, ma'am, what is the use of this thing? This thing will be used throughout this chapter and even other chapters that you will do, right? Now, see one thing here, that what basically they are telling you, what basically now they are telling you. They are saying that the acidic nature of substituted phenols. Substitute, we will substitute it, right? So you don't have to cram this here that, okay, NO2 is electron withdrawing, COH is electron. You don't have to do that. Why? Because tell me one thing, this NO2 means this thing. You will have something like this N double bond O, this is O, this is positive, this is negative. So basically, as you know that this nitrogen, which is more electronegative, oxygen is more electronegative as compared to nitrogen. That means this benzene ring is attached to a atom which is less electronegative as compared to the atom to which it is doubly bonded, right? That is why it is going to take out electrons from here, take out electrons from here. Definitely it is electron withdrawing in nature. Okay, if you talk about this bond, that is C double bond O, OH. Again the same thing, that carbon is less electronegative as compared to oxygen. So this is going to take out the electrons and then from the benzene ring, right? If you talk about C triple bond N, right? Again the same thing. Here it is triple bond, double and triple are same only, right? So here not same, but yeah, in this case it is same, right? So here this nitrogen is more electronegative as compared to carbon. That is why it is going to take out the electrons. That is why it is going to show minus M effect. So you don't have to remember these groups, right? You just need to know this particular trick here. If you know this thing, you don't have to cram anything, right? You don't have to cram anything. Here the example is, I'll also write down the example. The example is OH, OCH3, right? Because it has lone pair of electrons and it is not doubly bonded attached to any other atom which is more electronegative. Here the example is C double bond OH. Example is COOH. Example is NO2 and so many other examples, right? Okay, these are the basic things that you will see, right? Okay, now they are saying what is the effect of electron withdrawing and electron donating group, right? For that also there is one simple thing that you need to understand. I am talking about that a good acid is the one which after donating is going to form a stable carbocation. This carbocation should be very stable. If you are converting this Ha to A negative, this carbocation, carbon ion should be very stable. So this carbon ion, always remember throughout chemistry, you will apply this. These are the tricks by your Diksha ma'am, right? Very simple. Just always remember that your carbocation, it is basically like a money, and carbon ion, it is like a stress. So when someone, for example, it is positive, it is negative, it is like money. When you are poor in money, when you don't have money, someone is giving you money, you become happy, that means you become stable. Someone is taking out money from you. You only had 20 rupees. Someone is taking that 20 rupees from you. You will like, I want to punch you, right? So it will become unstable. It will be like, I am so poor and you are taking the money that I have, right? It will become unstable. Now someone is under stress. You are giving them stress. Someone like, I don't know, I'm not prepared for my NEET, right? You called up your friend, you are saying that I am not prepared for my JEE, yes, my JEE exam, right? Now, what will happen? Your friend will be like, two things can happen. First is a very good friend who will tell you, don't worry, just prepare well, right? Don't even waste a single day. Just be ready, right, till Jan, and you should complete everything, revise everything, do PYQs. It will motivate you, right? So that is basically they are taking out the stress from you. So when someone is taking out the stress, they are making you stable. They are making you stable. So for example, there is one friend who is saying that, oh, you have not prepared anything, nothing can happen, what you will do in 2 months, nothing can happen, oh my god, you are such a loser, you can't even do this. These kind of friends are also there. I have to completed everything, right? So they are basically giving you more stress, they are making you unstable, right? And here I was talking about when someone is giving, donating, so that is electron donating groups, this is electron withdrawing groups, this is electron donating groups, this is electron withdrawing groups. With a carbocation and carbanion, they behave differently, right? They behave differently. Now, now that was the thing. Now see students, here I am talking about when a group, here I am talking about electron donating groups, and here we are talking about electron withdrawing groups, because it is showing plus M, it is showing minus M, right? Now, once you know this thing, most of the conceptual questions of organic chemistry are already, you are already perfect in that, right? Okay. I am reading the chats and I am also reading that you guys are not talking about anything regarding to the topic. You are talking about unnecessarily things that are not even required, right? In the chat box, I want you guys to be a little active, right? But active as in not to the point that you are talking about this and that stuff, right? Talk about something related to this topic. Talk about that, are you able to understand this thing? Talk about, is there any question that you have regarding this topic, right? Okay. Yes. Everybody in the chat box. Okay. Now, this is electron donating group. As I told you, electron donating group plus M group, right? Electron donating group, that means you have a carbanion. You are giving the stress. That means they decrease the acidic strength of phenol. How they decrease the acidic strength of phenol? Because this was the carbanion. This was the carbanion, right? This was the carbanion. Any carbanion, when you are donating, when you are giving the stress to them, right? It is a negative, carbanion is negative. When you are giving the stress to them, they will become unstable. When this is going to become unstable, that means the carbanion is going to become unstable. That means phenol acidic strength is going to decrease here. So answer will be, there will be decrease in the acidic strength of the phenol. How many students are actually active here, right? Let me see. How many students are actually active here? Let me see, because it feels like I am teaching the walls, right? And this is, by that thing, it is difficult to teach, right? At least I need some response from you, that are you guys able to understand or not? If you feel like ma'am is sitting on a camera, ma'am is there in the camera, right? But guys, a teacher is someone who needs some response also from the students, so that I can know that if you're able to understand that or not. Otherwise, so it's like I'm teaching myself, right? I'm like, okay, do you got it, Diksha? Yes, Diksha, I got it, Diksha. Okay, then next page, right? If I'll start doing that, then I think you will be like, ma'am, I am not able to. Do you want me to feel that your opinion is not required, right? Do you want me to behave like that? I know there are some YouTube teachers who behave like that. They are teaching themselves, but I don't teach like that, right? And I never want to be that person. I am a teacher that was earlier in offline, right? I have that habit that I want my kids to have response that, yes, ma'am, we have understood this. Yes, ma'am, please, I have a doubt in this. Please explain this thing, right? It's not like I am teaching myself, right? I don't like that. I want you guys to interact with me. I don't want we both to behave as a robots, right? I am also a machine. You're also a machine. I'm saying yes, yes, yes. You're saying no, 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 nothing like that. Okay. So let's behave like humans, and humans do interact with each other, right? Humans do smile and humans do laugh, and you don't need to be so much serious when you are in the class, right? So yes, focus on the class, concentrate on the class, but also talk a little bit about the topic, what you know about the topic, right? Okay, yes. Even now I feel so many less students are here that are actually present in the class, and that is very sad to know. Okay, now next thing is reaction of phenol. I think I have not written here electron withdrawing group, I forgot, hai na? Yes. So electron withdrawing group. For example, you have a electron withdrawing group. What exactly electron withdrawing group is going to do? An electron withdrawing group, you have a carbon ion. Electron withdrawing group means you are taking out the stress from them. Carbon ion is negative. Negative means stress. When you are taking out the stress from someone, they will become stable. If your carbon ion is becoming stable, that means acidic strength is going to enhance. That means acidic strength is going to increase here. Right? Acidic strength is going to increase here. Now, next are some of the reaction of phenols. And here you have different kind of reactions, and the reactions of phenols are also important. Right? Two kinds of bromination, two kinds of nitrations. Right? Okay, we will see that. So if we talk about the bromination, there are two ways. If you are adding, when a reaction is carried out in the solvent with low polarity, such as CHCl3, CS2. And the other is when it is carried out in water, you will have different products. If you carry out the reaction in a non-polar solvent or a low polarity solvent, in that case, you will have different products. One is ortho and one is para. Para will always be the major product if no hydrogen bonding is there, right? So para product is the major product here. But if the same thing is done in presence of a polar protic solvent, right, in that case, what will happen? In that case, what will happen? Wait a minute. In that case, what will happen if that is done in the presence of water? In that case, you will have one product in which there is placement of bromine at ortho and para position. That means you will have 2,4,6 tribromophenol, which is a white precipitate, and this is also a distinguished test of, or you can say this is also a distinguished, or you can say a test of phenol. A test of phenol. A test of phenol. This is also a test of phenol. Because what are these tests? These tests simply means that you have a compound, which is, you have a reaction which is going to give you characteristic color or smell. Because here it is going to give us white precipitate, so then we can know that this is definitely a phenol which is reacting with bromine in presence of water to give us a white precipitate. Then definitely there is a phenolic group that is present there, right? That is why it is also the test of phenols, right? Now let us see the mechanisms of these two things. First is the mechanism of a CS2 group. What will happen? So here what exactly is happening here? You have this pi bond, right? Basically an electrophile is getting attached. All the reactions that we are doing here are based on the electrophiles, right? Here you have the electrophiles Br positive, right? That is why, as I told you, this is electrophilic substitution reaction. And phenol being a phenol, this OH being a group which has a lone pair of electrons, it will show plus M effect. That is why it is ortho para directing. That is why you will not see any group that is meta substituted group, right? So that is why all the electrophiles, they will attack on the ortho or the para position only, right? Okay, now let us see this. You have Br. From here you have CCl4, which is a non-polar solvent, right? It is going to generate this electrophile that is Br positive, which is going to attack on any of the ortho or para position, because at the ortho and para position there is negative charge, right? At ortho and para position there is negative charge, and there is this Br positive electrophile, so that is what is going to take place on the ortho or the para position, and hence you will have the formation of this ortho, and in the similar way you will have the formation of a para product, right? Okay, very good. Because of high polarity of its forms, that is basically, that lies in the mechanism, right? That lies in the mechanism of these two reactions, right? That are not there in your syllabus, so you can just skip that, right? But you should always remember that for a non-polar solvent, right, basically it is in the generation of the electrophile, okay, right? a non-polar or a polar solvent is going to affect the generation of the electrophile and how that electrophile is going to attack, right? A non-polar solvent is basically, it is not going to, the electrophile will be generated because this is a non-polar solvent, right? Or CS2 is a non-polar solvent. That is why it can attack individually and it can form ortho and para products. But when we talk about water, right, that is a polar solvent, right? In a polar solvent, you have already hydrogen bonding there, right? Because of those so many factors including there will be one attack at ortho and para position directly, right? Okay, so it's not one thing that is included here. There are so many different things. Because of that, here you have the mechanism is almost same. It's just that the rate will determine that here only it is attacking on only one position, right? But in the water case, you will have the attack on two positions, right? Okay. Similar is the case for nitration also. Okay. Similar is the case for nitration also. If you have dilute, now in dilute, you know that there is like water, but the concentration of the electrophile is less, right? The concentration of electrophile is less. That is why when you have dilute HNO3, here it is at ortho and para position. Two different products are formed. But if you talk about the concentrated, thing, right? Wait a minute, where is the concentrated? Yes. If you talk about the concentrated HNO3, you will have the attack simultaneously at ortho and para position, right? You have bromine water or you have concentrated HNO3, right? In that case, you will have one product which will be ortho para substituted. In case of non-polar solvents, in case of bromination, or you talk about dilute nitrating mixture, in that case, you will have two products, ortho and para products, different products, right? Now, how the electrophile is generated, that is the same thing. This is also important thing. Here you have two things, that is H2SO4 and you have HNO3, right? They can ask you which will behave as an acid and which is going to behave as a base. Now this is behaving as an acid, that is why it is going to lose H positive, right? It is behaving as a base, that is why it is going to accept H positive, and hence you will have the generation is going to accept H positive here, and when it is accepting H positive, it will become OH, this will be positive here. That is why it will take out these electrons and H2O will be eliminated, and hence you will have the formation of NO2 positive electrophile. The generation of electrophile is same, but the rate is going to differ whether you have dilute or concentrated, right? That is why depending on that you will have two products here, right? Now, next is if you talk about the major product here. If you talk about the major product in this case, right? In this case, major product is ortho. Why this is a major product? Why this is a major product? Because it is having hydrogen bonding here, right? It is having intramolecular hydrogen bonding, because of which it is more stable, right? Hence, it is a major product only in case of orthophenol, right? Orthonitrophenol. Otherwise, para will always be the major product, right? Okay. And this is what they have written it here, right? Now, next thing is how can you separate the ortho and para products? This is from purification and qualitative quantitative analysis. How you can separate these two things? See, for example, you are very close to your own parents, right? You are like, I don't want to think about anybody else. I am not very close to my relatives, right? I am only close to my parents, my siblings, right? Okay, you're not close to your neighbors, you're not close to your relatives. Now, because you're not close to them, so that is why it is easy to break the bond between you and the neighbors or your relatives, right? It is easy to break that bond. So the bond between you and your neighbors is basically, it will define the boiling point. Same means that the bond between two molecules is going to define the boiling point. If the bond between two molecules is very strong, the boiling point is very high. If the bond between two molecules, two different molecules is very less, bond is very weak, then the boiling point is also very low. As I told you, when you have intramolecular hydrogen bonding, you are very connected to your own family. You don't like your neighbors. You don't like anybody else. You are very close to your own family. You'll be like, my bond with my neighbors is weak, so it is easy to break. That is why it is having low boiling point. You give just little bit heat, it will convert itself into vapors. It will vaporize. It is steam volatile, right? Its volatility is very high. You just give it some little bit temperature, it will volatile. So it is volatile with steam only. You don't need to give it very high temperature, right? If you talk about this thing here volatility is very low, right? Why? Because it is not very close to the family, it is very close to the neighbors, to his friends, to his relatives, right? That is why it is very difficult to break the bond between that person and the relatives, right? It is very difficult to break that bond. That is why it has high boiling point and it is very difficult to convert it into vapor, so it has less volatility, right? That is why by steam distillation, we can separate ortho and para product, because this is steam volatile, this is steam less volatile. Okay guys? Okay guys? Yes. Now, this also done. Next is sulfonation. That is you are converting this, you are adding you are basically doing the reaction with oleum or very high fuming H2SO4. Then what you will have, right? So it is going to give us two things: concentrated H2SO4 at 20-25 degrees Celsius. It is going to give us SO3H at ortho or para position, right? At ortho or para position, right? Now this is, they are telling you about the generation of the electrophile, that how the electrophile will be generated. You will have a molecule of H2SO4, this is another molecule of H2SO4, right? So any of these two will take out H positive from the other one and you will have the formation of this thing and this thing. For example, here this O, the lone pair of this oxygen is going to take out this H positive, then it will become SO4H negative, right? SO4, that means HSO4 negative. Now this will become, because it will take this H positive, so it will become, this will be one H here and this will become this positive. Now because of this thing, oxygen can't handle positive charge, right? The electron negative elements, they can handle negative charge, but they cannot handle positive charge. So they would want to give off the positive charge, right? So how they will do that? It will take out this electrons from this bond and this will become HSO3 positive, right? And this will become your electrophile, right? Okay, it will attack on the benzene ring and you will have the formation of ortho and para products. Next is formation of picric acid by sulfonation. We studied about the picric acid formation by nitration. Now let us see by sulfonation how you can make this. This is also your PYQ, right? This is important, right? This is important. The mixture of ortho and para hydroxybenzene sulfonic acid further heating with concentrated HNO3 forms a picric acid. How? Let us see. You have the formation of this ortho and para substituted sulfonic acid, right? Now what will happen? You give it concentrated HNO3, right? Just concentrated HNO3, not full nitrating mixture, not H2SO4. Just concentrated HNO3. It will convert this sulfonic acid to picric acid, right? Okay, so this is by sulfonation how you can form picric acid, right? Yes, definitely MS Chauhan is a very beautiful, amazing book for organic chemistry practice questions. It's a very, very interesting book also. You will like it when you solve the questions, right? Okay. Next is Kolbe and Reimer-Tiemann reaction. So Kolbe's reaction is what? In this case, reaction of sodium phenoxide with carbon dioxide, right? This will generate what kind of thing? Let us see the mechanism. Firstly, let us see the mechanism, what is going to happen here, right? Okay, everybody, let us see the mechanism. Now see this thing. You have phenol, right? We know that why it is giving H positive, because in the presence of a base, that is NaOH, it is going to, base will take out this H positive, right? Because here you will have the formation of, you will firstly add NaOH here, right? Because of this NaOH, it is a base, it is going to take out this H positive from here, right? So because it is acidic in nature, it will give out this H positive, and this is going to take, this NaOH is going to take out the H positive, and hence you will have the formation of phenoxide ion here. Now, from this phenoxide ion, you will react this with CO2, that is carbon dioxide. And what is the molecule of carbon dioxide? This is having a linear shape, that is CO2, right? It is having two double bonds here, right? We know that this is partially negative, this is partially negative, this is partially positive, right? And because of here, in the phenoxide ion, we know one thing, that there is, because of resonance, this electron will jump here and this electron will jump here, right? You will have a ortho substituted here. Basically what will happen, if I talk about the phenoxide ion resonating structure, this is one of the resonating structure of phenoxide ion. This is one of the, that we have drawn this before, right? I think 30 minutes back only we drew this thing, right? About the structure, resonating structure of phenoxide ion. So these resonating structure of phenoxide ion, now it's not necessary that this will happen only at ortho position. Majorly the product is ortho. I'll tell you what is the reason behind that, right? Majorly the product is ortho because in the end, this H will have hydrogen bonding with this oxygen. That means you will have a stable product at ortho position. That is why para is not included here. Shreyas sir is here. Let's complete it now. We have best chemistry lectures. Yes, sir, definitely. And even I am very, very excited for completing the full syllabus and doing the revision here. Yes. Thank you so much, sir. Thank you so much. Yes. Now, guys, as you can see here, 2-3 things, okay? First thing is, students always assume that, ma'am, only ortho product is formed. That is not true. Very rarely it is mentioned, but yes, para product is also formed here. Why ortho product is more stable? Because it is having hydrogen bonding here. That is why it is more stable, right? That is the first answer, first question, right? Second is, what is happening? Ma'am, why we have taken ortho? Because definitely in the end it is more product, it is more stable. That is why we are seeing the mechanism for salicylic acid where you have ortho product, right? We know that when we were doing the resonating structure of this phenoxide ion, this is one of the structure. This is one of the structure. And this is having, this carbon dioxide is having this kind of molecule, this kind of electron density. This is positive, this is negative. Positive, negative, positive, negative. They will attract each other. And this carbon dioxide, this carbon is going to get attracted towards this negative, right? And always, always remember, in mechanisms of chemistry, in organic chemistry, always the arrow is towards, from negative to positive. If someone is drawing it like this, it is wrong. It is wrong. Right? It is never, never, never from positive to negative. That is totally wrong. Right? Okay. So here you will have, you will always draw the arrow from negative to positive. Right? Now, we know that this carbon will attach here. Right? Now, see students, one thing. What you will have? When this phenoxide ion, I'm talking about this particular thing. That phenoxide ion, you will have this thing, negative, and this is double bond. Oh, I am saying that carbon dioxide, which is having this kind of positive, this is negative, it is going to attack here. So what will happen? You will have the formation of this thing, carbon, double bond O, double bond O. Is this right? No. Carbon can never have carbon is not pentavalent. Carbon can never have 5 bonds. So one of the bond, one of the electrons, it will shift here. So it will have O negative here, right? You will have, that is why after this you have drawn CO negative here, right? Okay. Now, once you have this thing, now again what will happen? See, We know that here, okay, wait a minute. Where was the mechanism? Yes. Okay. Now, here we know that here it must have one hydrogen before that, right? One hydrogen should be there. Now, here in this carbon also the tetravalency is completed. If I inter-exchange this hydrogen to this position, that means the electrons jump here, right? These electrons jump here, and this hydrogen jumps here. It will become double bond, double bond, double bond. This is O. This hydrogen will jump there. It will become O double bond. This is O negative. Then I'll just have to add one H positive here. It will become OH. That is your salicylic acid. Right? So it is a very simple mechanism. It's not a very complicated mechanism here. Right? After interexchanging, you will have OH. Then you will add here. They have done firstly, they have added Na positive here. Right? From that NaOH only, Na positive will attack here. It will become ONA. Then you will add HCl here. Then it will become, in the mixture, you cannot tell that, you cannot order the molecules. Like NaOH, you can't react now. Now HCl will react. You can't order them, right? They are going to behave the same way in the reaction mixture you will give them. Here in the reaction mixture, in the beaker, in that reaction mixture, you have NaOH. You have that base. So the base is definitely going to take out this H positive. Then again, when the base, this Na positive from the base, when it will see O negative, it is going to attack Na positive there, right? And you will have the formation of ONA. And after how you can replace Na positive, just do the acidification by adding HCl, you will have the formation of salicylic acid, right? Okay. And this is a very, very useful compound for pimples like these. It is very, very useful, right? Okay, yes, I have a very beautiful, not a very beautiful, but a very crazy relation with salicylic acid. I'm always like in need of salicylic acid in my body. Isn't it? How many of you are actually in need of salicylic acid, especially when you are a teenager? You need salicylic acid daily in your life, right? So you should always use face wash that have salicylic acid. It is that much important, especially in your puberty, when you are, you have so many hormonal changes in your body and so many acne on your face, and right now so much pollution is out there, right? So definitely those students who have these kind of problems, salicylic acid is like a very good thing for them, right? Now next is Reimer-Tiemann reaction. Reimer-Tiemann reaction. Yes, thermal physics. Now let us see Reimer-Tiemann reaction. In Reimer-Tiemann reaction, we have the formation of, from phenol, we will make aldehyde, right? We will make aldehyde from here. That is CHO. Now, this mechanism is very, very interesting. Okay, the mechanism is actually very interesting. This is also somewhat very related to carbylamine reaction, isocyanide reaction that we will do in amines. Now, see. Basically, here remember one thing, the electrophile, very, very important thing. Electrophile is going to be a carbene. You have understood. Ma'am, carbocation, carbanion, ma'am, benzene, that was in Dow's process. Right? In this also you have a very interesting electrophile that is not like carbanion or free radical. It is a different electrophile which is called carbene, and here you will have dichlorocarbene is going to be your electrophile, and this will be generated by CHCl3 and KOH. When you have a combination of these things, you will have the generation of an electrophile, that is CCl2 and 2 electrons here. Why it is an electrophile? As you can see that here CCl and 2, 1, 2, 3, 4, 5, 6, totally it has 6 electrons. Now carbon is complete in its octet, it needs 8 electrons, but now it is having just 6 electrons. It is deficient, right? So that is why it is electron deficient. It is attracted towards electron species which has more electrons. That is why it is called electrophile, electron loving. Phile means loving, electrophile, right? So now let us see how the mechanism is going to work here, right? Okay, so here too they have given you mechanism in a very rigid manner, right? Okay, so we will do the mechanism in, no. Yes, they have given you mechanism in detail. Yes, the mechanism in detail. Let me see if it is given or not. Yes, it is given in detail. Okay, so let us see the mechanism in detail, right? Because it is important. Some of the mechanism in chemistry, especially in alcohol, phenols, ethers, and some of the mechanism is aldehyde, ketones, carboxylic acid, and one or two mechanism in amines like carbylamine test, right? These are very, very important, right? Okay, yes, when we talk about competitive exam also, that is important, right? So now let us see this thing. Now firstly, let us generate this electrophile, dichlorocarbene, right? The same thing will be applied in carbylamine test that we will do in the next chapter, right? Now see, you have two things, that is CHCl3 and NaOH or KOH, right? So what will happen? What is the work of a base? A base is always going to take out H positive. An acid is always going to donate H positive. So base is going to take out H positive from wherever it can. So it has CHCl3. It is like, okay, CHCl3, I am a villain in your life. I will take out H positive from you. Right, so it is going to take out H positive from here and it will become CCl3 negative because H positive is taken out here. Right, that means here this positive has gone without the electron, so that is why it is this negative here, CCl3 negative. Now you have this reaction, right? Now in this CCl3 negative, ma'am, how this carbene will be formed, right? So what will happen? Again, this Cl negative is going to eliminate from this side and you are going to have this negative means 2 electrons, right? And hence you will have the formation of this dichlorocarbene, right? You will have the formation of this dichlorocarbene, a very, very important intermediate, right? Okay, it's a very, very, very important intermediate. Now students, if you talk about, students, tell me till here, are you able to understand or not? Right, everybody in the chat box, right? Everybody in the chat box, kids, please, yeah, please answer something, okay? Otherwise, I'll sleep off in the class itself. Yes, even I love myself. Don't worry, I am like that only. Okay, now tell me, a Reimer-Tiemann reaction. In that, firstly, we have generated this dichlorocarbene. Now, what will happen again in the reaction? How this electrophile will attack, right? Let us see that. So if we talk about this phenol, definitely when you have KOH in the reaction, that means a base in the reaction. This base is going to take out H positive from here as well. It is going to form this phenoxide ion. Phenoxide ion has this resonating structure, right? Where you have, because the electrons are going to jump here, this electron is going to jump here, and this, till here everything is same as Kolbe's reaction, right? Till here everything is same as Kolbe's reaction, but after this things are going to change. How the things are going to change after this? See this very carefully. Now you have the electrophile is not carbon dioxide, the electrophile is dichlorocarbene, that is CCl2, and this 2 dots here, that is the 2 electrons, right? So this is electron deficient, as I told you, because it has 6 electrons. It is going to attack here, right? This is your negative, this is positive. So what will happen? What will happen? This CCl2 will be attached here, right? Then you have this negative here, right? Okay, because of this negative, wait a minute, why this negative is here? CCl2 negative. This negative, let me take out this negative from here. You will have the attachment of CCl2, right? This carbon will have 2 bonds here, right? So this will be the product. Now what we are going to do next, we are going to, this is H positive, this is your H here. The same thing is going to happen here, just wait a minute, okay? Stupid people in this universe. Okay. Yes. Now, let us see this thing here. Okay, back to the work, back to the work. I think Capto has handled it really well. Now, let us see, this is H, right? Now, this sigma electrons, because we are going to internally shift this H positive to this side, right? So, exactly what will happen? This electron is going to jump here. This electron is going to jump here, right? This electron is going to jump here. This electron is going to jump here. You will have a negative over here, right? Now, understand one thing very beautifully. Now, this is your CCl2. This okay. There was this negative was needed. This negative was basically to this side. Students, I am making this again because there is one mistake you have here. Okay, I am going to draw it on the next page only, right? See, you will have this thing. You will have this thing, right? After the resonance, the answer will be double bond here, and this is a negative. Now, when we are attacking CCl2 here, right, it is going to attack here, then what will happen? You will have the formation of this double bond is going to stay as it is. This is double bond, this is double bond. Then, because of this thing here, definitely this is CCl, Cl. But this carbon, which is only having 3 bonds here, right? So it is going to have a negative charge over here. Why? Because of these two electrons. These two electrons here, it will have a negative charge over here. Understood? Why this carbon has a negative charge? Because of these two electrons here, it has a negative charge, right? Here also it is negative, here also it is 2 electrons. The bond is going to form between this carbon and this carbon and this carbon because of this negative charge. Now you are still left with 2 electrons. That is why you have a negative charge over here. That is why you have a negative charge over here, and here you have hydrogen, right? Now what will happen? The electrons is going to shift here. This pi bond is going to shift here. This hydrogen is going to shift here to this carbon, right? So here you will have, this is double bond, double bond, double bond. This is O negative. This H, Cl, Cl, and this is H. Then you will add QH. Then you will add QH. Then you will add QH. Then this Cl will be converted to OH. Then this Cl will be converted to OH, right? This is Cl. We know that whenever you have to replace Cl with OH, you just have to add QH aqueous, right? That we already have in the medium, right? So that is why it is going to convert it to OH. Now on a carbon, 2 OH groups are never stable, right? On a carbon, right? 2 OH groups are never stable. Whenever you will see, this is carbon, this is OH, okay? Whenever you see this is carbon, this is OH, this is OH, it is the most unstable thing. So what will happen? One H positive will go from this side, this double bond is going to shift here. Always and always you will have this thing. And hence after that you will have the formation of OH, and this is double bond. Always this will happen when you have on one carbon. Throughout chemistry you can see this. In so many mechanisms you will see this thing, that when you have 2 OH groups on one carbon, it's not possible. It's like, you know, that influencer is having 2 wives, right? So it is not possible. People can't handle one wife and he is handling 2 wives. How that is possible, right? So that is why one wife is always going to leave him. Don't worry, just see, right? So now what will happen? This H positive will leave here, and this pi electrons are going to shift here. You will have the formation of carboxylic acid group, right? Okay. Wait a minute. Here we had CCl2 or CCl3. We had CCl. Wait a minute. Yes, we to have the formation of CCl2. No, yeah, this will not happen. Wait a minute. Let me draw that again. Here, wait a minute, this is OH, this is OH, and this is OH. Okay, there is one hydrogen also, right? So here you will have the formation, it will leave water here. Yes, I forgot about this hydrogen, right? That will happen if you have 3 hydrogen. Wait a minute, I'll show you one more thing about this particular reaction, right? Two possibilities. One possibility is that if you have COH, OH, right? Second possibility is this one, right? So when you have 2 OH and 1 hydrogen here, then what will happen? 1 H positive to will leave from this side. Then 1 OH will leave from this side, right? And hence you will have the formation of, wait a minute, 1 H positive is going to leave from this side, or you can also say that 1 H positive is going to leave from this side because water we have to take out, and this double bond is going to shift here, and this OH negative is going to leave from this side because oxygen cannot handle, this carbon cannot handle 5 bonds, right? So this OH negative also have to leave. Then you will have the formation of this thing, that is O negative, and this is C, this is double bond O, and this is H, right? This is basically your salicylic aldehyde will be formed here. After this you will add NaOH, right? Then after this you will add HCl, this O negative will be OH, right? So after this, so very simple, what you will do, after this you will add, instead of just writing it here H2O, you should have add NaOH, and after that you will have HCl, right? Then you will have the formation of salicylic acid, salicylic aldehyde. But now, one question is, for example, in the Reimer-Tiemann reaction only, the reagents are CCl4 and KOH. Right? If you have CCl4 plus KOH, then the answer is going to be salicylic acid. Because in the end, you will have CCl3 that will be attached here. And when you replace that CCl3, because here you will have CCl3, CCl, right? One Cl will be eliminated to form the carbene, but in the end, you will have Cl over here, right? Now, when you replace this, it will become OH, it will become OH, it will become OH. Then in this case, what will happen? In this case, what will happen? One OH negative is going to leave, one H positive will leave, one double bond will attack here, and hence you will have the formation of salicylic acid, carboxylic acid you will have, right? This is COH and this is double bond O, right? So these are the two things that you should understand. I am writing it here. For example, you have CHCl3 plus KOH. Then you have the formation of aldehyde group. But if you have CCl4, they can ask you in Reimer-Tiemann reaction, how can you make salicylic acid? You can make by using CCl4 and KOH. That is this will become carboxylic acid. Carboxylic acid, that means salicylic acid will be formed in this case. Okay, salicylic acid will be formed in this case. Okay, understood guys? Yes, okay. Now, next is, this is a very simple reaction. When you react phenol with zinc dust, it is simply going to form zinc oxide and benzene, right? It's also important reaction. It has been asked in your latest questions, right? Latest exam you have seen, because the questions are not tough. It is just to retain these many reactions is the tough part, right? Okay. Again, this is also very important. It's an oxidation reaction where what will happen? You will have the formation of this. Compound. When you are using a very good oxidizing agent, right? When phenol exposed to air or sunlight, it undergoes oxidation to pink color compound, that is para-benzoquinone, right? And this is also, they can also write Na2Cr2O3, right? This also can be written, right? So this is a very important compound, a very important and a very different reaction this is, right? So benzoquinone or hydroquinone will be formed here, right? Next is, when you have the reaction of phenol with K2S2O8, then what will happen? This what we have done in the starting of this chapter, right? That catechol will be formed or quinol will be formed when you will have the reaction of phenol with K2S2O8, right? Direct reactions you just have to remember here. No mechanism, nothing is needed here, right? Next is very important. These three reactions are different reactions, right? For example, you are talking about a salicylic acid, right? When salicylic acid is reacted with a acetyl group, you can say CH3COCl in the presence of pyridine, then acetylation will happen here. That means this OH, this O group, this H group, right? This H group that you basically, this is acetylation, okay? That means this COCH3 will be replaced by this H group here. So that will become COCH3. Instead of this H, you will have COCH3. It's a very, very important compound, that is aspirin. Now it is banned in India, right? It is basically, I think, used for thinning of the blood, right? So that is why it is banned in India, because our body is specified in, it is forming blood. It is very good in forming blood. For example, you have some, there is some blood going on in your, I'm saying. For example, you have some kind of injury on your body, right? Now what can happen? Your body will, after some time, it will form a clot itself, right? Because our body blood is made like that, right? But when you use this kind of medicine, our blood is getting thin and thin, right? After every medication, when we take the dose of aspirin. That is why it is banned in India now, but some people take it. Sad part that is don't know what is the reality here, right? Then you have CH3OH in acidic medium, right? Here what will happen? This H positive is going to replaced by CH3, and this is called methyl salicylate oil of winter green, right? This is called methyl salicylate, right? Here what happened? This H was replaced by COCH3. Here this H was replaced by CH3. In this case, in the last case, you have when OH and this is phenyl, and in the acidic medium what will happen? This H will be replaced by this phenyl here, and it's a very important compound called cellol, or this is called phenyl salicylate, and the common name is cellol, right? So these are the important reactions for when we talk about JEE mains or JEE advanced, right? These are the very, very important direct reactions that they can ask you, right? Very important. These are three reactions, okay? Yes. Now, next is with diazonium salt. So basically here we are talking about coupling reactions, right? So in coupling reaction with diazonium salt, if you have phenol, right, we will talk about with aniline also what it will give. Right now we are talking about coupling reaction with phenol. With phenol here what will happen? This HCl will be eliminated, and hence you will have the formation of this benzene N2, and then this benzene and this OH. This is called para-hydroxyazobenzene, and this is having a orange dye. Orange color dye is formed here. A very important color you should remember, right? It is also a test of like you can distinguish that what you have. If you react any X solution with diazonium chloride, what will happen? If it is giving you azo dye which is orange in color, then you can say that this is basically the compound was phenol, right? So here also you can test the phenolic group, right? Okay guys, now let us see phenol when it is first reacts with concentrated sulfuric acid and then with concentrated nitric acid. If you talk about with concentrated sulfuric acid, if it reacts first, then with concentrated sulfuric acid, what it will give us? Everybody in the chat box, what it will give you? We have done this reaction even like just 10-15 minutes back, we have done this reaction. When phenol reacts with concentrated sulfuric acid, it is going to give us sulfonic acid. Then with concentrated nitric acid, it is going to give you which thing? Picric acid, right? Picric acid, and the IUPAC name of picric acid is 2,4,6 trinitrophenol. Right, so answer is B is the correct answer here. Right, B is the correct answer here. By which process phenyl acetate can be converted to hydroxyacetophenol? By which process? Now this is a different reaction. We have not done this reaction, right? So let us see this reaction, right? Basically the answer is Fry's rearrangement. Let us see what exactly is Fry's rearrangement. In this, you will have your benzophenol, not benzophenol, acetophenol, right? You will have acetophenol. So now what will happen? To this, you are reacting this with catalyst AlCl3 and aqueous HCl, right? So what will happen? This CO, this particular group, it is going to attach to the ortho and the para position, right? This particular group is going to attach to the ortho and the para position, and one H will be added here. That is basically called Fry's rearrangement. In that same compound, these two compounds are rearranging with itself by the addition of a catalyst, that is AlCl3 and aqueous HCl, right? Okay, so here what you have, the hydrogen from here, it will come to this position, and the OCH3, it will come to this position, right? This is basically called Fry's rearrangement, right? So now let us see the question what they were asking. When phenyl acetate, yes, phenyl acetate can be converted, so it was phenyl acetate, yeah, I told benzophenol, no, yeah, that was ketone, right? So this is basically your phenyl acetate. Now why phenyl acetate, right? Because one group is your phenyl group and this group is your acetate group, right? This group is your acetate group and this group is your phenyl group. That is why phenyl acetate. Okay. Next is, again, this is a different reaction, right? So here carbon monoxide with H2 in presence of CuO or ZNO or CrO3, right? With very, very high temperature, what it is going to give you? First is methanol, second is methane, third is ethane, fourth is ethanol, right? What it is going to give you? Anybody in the chat box? Anybody? I'll give you one hint. It is any of the alcohol, methanol or ethanol. Methanol or ethanol. Yes, everybody, methanol or ethanol. Yes. The answer is methanol is the correct answer, and methanol is not good for our body because in our body methanol produces methanoic acid. That is the reason ethanol is basically that alcohol is used, right? This is basically alcohol, right? That is for drinking purposes, right? Also it is added in some of the medicines, right? In cough, right, you will see a very different smell. It's not like a very, like, that is why you feel like totally out when you are like having cold or cough, when you are drinking those kind of medications, you will feel very sleepy after that. Why? Because they freeze your brain for some time, right? Okay. And now this methanol is not good for drinking purposes. Why? Because it is converted to methanoic acid, which is very dangerous for our body, right? And also one more thing, that this ethanol, that is for drinking purposes, and this methanol, they are also mixed together, right? And sometimes what actually is done in industries, if you want to use ethanol, but they don't want anyone to drink it, so they will add copper sulfate into it. They will add pyridine into it, so that a very foul smell it can produce, and that is not, so that everybody, for example, you are drinking something which has a very bad smell. Will you drink it? No, right? Okay, so that is why these kind of things are added. That is called denaturation of alcohol, right? Okay. Now, next is test for phenolic groups. Now, basically, guys, you have these 5 tests of phenolic groups. One is litmus test, ferric chloride test, Lieberman's test, bromine water test, and phthalate test, phthalate dye test. So, all of the tests are very important. If you talk about litmus test, phenol is an acid, right? That is why it will convert a blue litmus paper to red. Blue litmus paper will be converted into red. That is litmus test. Very simple, they will not ask you this. Right? If you talk about ferric chloride test, let us see. What is ferric chloride test? In ferric chloride test, if you talk about this phenol, when it is treated with ferric chloride, it is going to give you a violet colored complex. So in a ferric chloride test, by adding ferric chloride, if you have violet colored complex, then you can say that yes, there is formation, there is a phenolic group present in this particular structure, in this particular compound, right? If you talk about the next test, that is Lieberman's test. Now in Lieberman's test, firstly let us see the reaction here. You don't need to learn the full reaction, just learn the end product here. What are the color changes that are happening here, right? So phenol, when it is reacted with NaNO2 and H2SO4, now remember one thing, Lieberman's test is only given by those phenols where para position is free. Where para position, there should be no group should be attached to the para position. Okay, only then it can give you that test. So now, in the para position, what will happen? You will have the substitution of NO, right? After that, further you will have if you further add more phenol and H2SO4 into it, you will have the substitution of this particular thing. After adding NaOH, now what is the color? You need to remember the color here. In Lieberman's test, the color is, if blue color appears, right, on adding NaNO2 and H2SO4, then you can say that it is having phenol, right? It is having a phenolic group. By adding NaNO2 and H2SO4 and NaOH, you can say that if blue color appears, then yes, phenol is present, right? That is called the Lieberman's test, right? Phenol reacts with concentrated sulfuric acid and sodium nitrite, forms a yellow color quinine monoxime complex with excess. You just have to remember the excess one. With excess of phenol and sulfuric acid, a deep blue iodo-phenol complex is formed. On further dilution, a red color iodo-phenol is formed, which turns into deep blue color on sodium salt of solution iodo-phenol treatment with sodium hydroxide. So just remember the last case, that in the end what you will have a blue color. A deep blue color will be formed, right? Okay, that is called the Lieberman's test. Next is phthalene dye test, again a very important test. Phthalene dye test, let us see the reactions directly, right? In this case, what you need to remember, this pink color, right? So exactly, when you add phthalic anhydride into the phenol, right, you will have the formation of colorless phenolphthalein, right? Colorless phenolphthalein is made here. After this, when you add NaOH, for this colorless will be converted to pink color, right? Then you will add excess of NaOH, then it will be again converted to colorless, but you don't have to remember this thing. But just remember that when it is reacted with phthalic anhydride in presence of H2SO4, it is converted to a colorless phenolphthalein, right? Why this test is important for you? Because this compound is very important for you. This you will see also in other practical chemistry also you will see this, right? So here this is again converted to pink color on adding NaOH. This is the transformation that you want to see in phthalic dye test, right? Okay. Now phenol on heating, this basically in theory part they have written here, right? So what the change that will happen, right? Okay guys, yes. So guys, that was about ethers. Now let us do some questions on the basis of alcohols, right? Okay, so let us do some questions. Some questions we will do now, some questions we will do after the break, okay? Now let us see this question because we have just gone through these reactions. So let us see, these are your previous year questions only, right? Let us see if you are able to do this or not. Okay, now let us see. I think you guys are more interested in talking to each other than solving the questions, huh? Is it? Now, this is list number 1. This is list number 2. You have to match these two lists. So let us see if you're able to match this or not. Everybody in the chat box. Okay, Simon is saying, Sai is saying C. Okay, what about Dharan, Kevin, Ganga, Rafia? Very good, Kevin is saying C. Okay, let me see if C is the correct answer or not. Okay, C for Chennai. Let us see if that is the correct answer or not. Okay, now first is when you have phenol and Zn plus heat, then definitely zinc dust plus heat, you will have the formation of benzene plus zinc oxide. So A is 3. A is 3. Phenol with CHCl3, NaOH and HCl, you will have the formation of, this is salicyl aldehyde. So B is 1, B is 1, A is 3, B is 1. A is 3, B is 1 is not there in any other option. So answer will be third only. But still we will see if other two are correct or not. Phenol with CO2. This is Kolbe's reaction. Right? This is Reimer-Tiemann reaction. This is Reimer-Tiemann reaction. Right? So here the answer will be, you will have the formation of salicylic acid. That means C is second. Last is with concentrated estrus of HNO3. Concentrated HNO3, you will have the formation of substitution at ortho and para position, both at the same time. So you will have the formation of picric acid. That means D means fourth. Right? So C will become the correct answer. Wasn't it easy? Simple, easy question. Third question, your PYQ. Right? Next is you have the formation of, this is the statement. The statement is para-nitrophenol. The statement is para-nitrophenol is more acidic as compared to meta-nitrophenol and ortho-nitrophenol. Okay. Para-nitrophenol. So students, firstly let us draw the three things here. Para-nitrophenol. This is phenol. Para-nitro. Ortho-nitro. This is meta and this is ortho. And this is ortho. Now, I don't know if you remember GOC or not, but I will try to recap this thing, right? So, mesomeric effect is not applied on the meta position, right? It is only applied on the ortho and para position. That is a rule, right? That is a rule. Now here, because this is connected to nitrogen, so it is showing minus I, because it is at para position, and NO2 is also having minus M effect, so it is showing minus M. It is showing only minus I effect. It is showing minus I and minus M. Right? Now see, more is the electron withdrawing effect. More stable will be the carbon ion. Right? More stable, more acidic will be that thing. Right? So now, as you can see here, if you talk about the acidity order here, if you talk about the acidic order here, acidic order is going to be, this is having least withdrawing group, right? It is not having a very high withdrawing group because it is only showing minus I effect, right? So that is going to be, because it is having very less electron withdrawing group, that is why it is very weak acid. So if I am saying this is para, this is meta. So meta is a very weak acid. Then if you compare with para and this one, right? Para and ortho. As you can see, here it is also showing minus M, here also it is showing minus M. So minus M is same for both, but minus I operates via distance, right? So here the distance is more, that is why minus I effect will be less. But one more thing here, it is having hydrogen bonding. It is having hydrogen bonding. So it is very difficult to it is very difficult to lose this H positive because it is having a hydrogen bonding. It will not show any acidity order because it is very difficult to lose H positive. You are already bonded to someone. So it is very difficult to break that bond and lose H positive there, right? So that means ortho is even weaker. Ortho is even weak, right? Para will be maximum because it has no hydrogen bonding. It has minus I minus M effect. This is the acidic order. So can I say this is a correct statement? Para nitro is more acidic than meta and ortho. Yes, that is the true statement. It is true. Ethanol will give immediate turbidity with Lucas test. Ethanol, that is, ethanol means CH3, CH2, OH. This we have done before, right? This I told you that this is a 1 degree alcohol. So 3 degree will give us immediate turbidity. 2 degree will show some kind of tantrums. But 1 degree is going to be next level. It is like, I don't want to go with you. It's like, I will only show turbidity if you give me so much heat. That is why they are saying immediate turbidity, it is false. So answer is statement 1 is true, but second is the false. So first is the correct statement. First is the correct answer. Right? Okay. A is the correct answer. Right? Next is phenolic group can be identified by a positive phthalate dye test, Lucas test, Tollens test, carbylamine test. Firstly, students, carbylamine test is for amines. This we will study in amines. Tollens test is for carbonyl groups. Right? This we will study in aldehyde ketones and carboxylic acid. Lucas test will differentiate between 1 degree, 2 degree, 3 degree alcohol. Right? Phthalate dye test is for phenolic group. So answer will be first is the correct answer, and this is your previous year question of 2024. Right? Okay. So questions are not difficult. Questions are easy only. Just you should prepare well for your questions. Right? Okay. Now next is this one. Right? Next is this one. Again, try to answer this. Try to answer this, everybody in the chat box. Try to answer this. Let me see how many of you. Sai, Dharan, Lokesh. Now they are deleting the messages. Shiva. Okay. Now, as you can see this here, this is basically phenol is giving us salicylic acid. That is possible. Salicylic acid is possible with CO2, HCl and this. That means fourth is the correct answer. A is with fourth. A is with fourth. So that is only possible in 2 cases. Second and third option is eliminated. Right? Then you have this phenol, it will give rise to salicylic aldehyde. Salicylic aldehyde is possible only in case of Reimer-Tiemann reaction, and the reagents are CHCl3 and wait a minute, here it is then NaOH and here it is HCl. Yes, that is the third part. So answer is B is with third. B is with third, so this is the answer. Then you have alcohol to this benzoquinone. Then you should have this Na2Cr2O7 and H2SO4. So answer is first one. So C first. Right? Then there is, when you have C is first one, then the last one is you have phenol and you need to convert. You just need to replace this H positive with CH3. Then if you add NaOH, it will be replaced by ONA. Then after that, when you add CH3Cl, this will be replaced by CH3. So answer will be second. D will be second. So answer is fourth is the correct answer. Yes, very good. Fourth is the correct answer. Right, very good, very good. Now, next is this one. This is based on ethers, right? This is based on ethers. Wait a minute, let me see. this question, this is based on phenol, right? So I am completing the questions, previous year question of phenols here, right? Phenol treated with chloroform in presence of sodium hydroxide, which further hydrolyzed in the presence of an acid, results in salicylic acid, benzene 1,2-diol, benzene 1,3-diol, 2-hydroxybenzaldehyde, right? 2-hydroxybenzaldehyde. Everybody in the chat box, 2-hydroxy, they are saying chloroform, that means CHCl3, in presence of NaOH4, that is further hydrolyzed in presence of acid, results in which thing? Here they are talking about which thing? They are talking about Reimer-Tiemann reaction, where you have the formation of salicylic aldehyde. So answer is salicylic aldehyde, that is called 2-hydroxybenzaldehyde. So answer 4th is the correct answer, right? Okay, very good, very good, very good. 4th is the correct answer. Next is salicylic aldehyde is synthesized from phenols when reacted with. Salicylic aldehyde is synthesized from phenol when reacted with which of the following, right? Okay. So from phenol to salicylic aldehyde, simple. Can you see in different set the same kind of question is getting repeated, right? So salicylic acid from phenol, how you can make this? By adding CHCl3 and NaOH. So answer is 4th is the correct answer again, right? 4th is the correct answer. Next is statement based question. You have assertion reasoning question. Alcohol reacts with as nucleophiles and electrophiles. Okay, that is true. Alcohol can behave as nucleophile, electrophile, that we have seen in the previous lecture, right? Alcohol react with active metals such as sodium, potassium, aluminium to yield corresponding alkoxide and liberate hydrogen. That is also true, right? Because ROH, this is acidic in nature. When it reacts with the metal, it will give you RONA, which is a salt, corresponding alkoxide plus H2. That is also true, right? Now, can I say, are they related to each other? Why alcohol react with metal to give RONA? It has nothing to do with this nucleophile and electrophile. So, answer is both A and R are true, but R is the correct. It is not the correct explanation. So, 4th will be the correct answer, right? They should have given, it's not like this is the wrong statement, this is the correct. But if I am saying why this reaction is happening, it is happening because alcohol is acidic in nature. It is not happening because it is acting as electrophile and nucleophile both, right? That is not the reason for this reaction to occur, right? So answer is D is the correct answer, right? Can you see so many questions based on the concepts like acidity, basicity, right? Next is, given below are two statements. One is labeled as assertion A, the other is labeled as a reason R. They are saying pK. Now remember, Ka is inversely proportional to pK. pK value of phenol is 10, while that of ethanol is 15. Okay, that means you are saying Ka value of phenol is greater than ethanol. Because you clearly don't remember the values, right? They are not asking you to remember the values here, right? They are just twisting the question here. If pK value of, if you are saying that pKa value of ethanol is greater than phenol, that means Ka value of, because of this relation, phenol will be greater than ethanol. Is it true? Ka value means acidity they are talking about. Is it true? Definitely phenol is more acidic because of resonating structures. Because phenoxide ion, this ion has resonating structures. But CH3, CH2O negative, it is not under resonance. That is why this ion, this carbon ion is more stable. That is why this is a good acid. Right? That is why phenol is a better acid. So that is true. We can say this is a true statement. Ethanol is stronger acid than phenol. Definitely not true. Phenol is stronger acid, right? So answer will be A is true and R is false. A is true and R is false. Yes, students? Okay. Very good, very good, very good. So A is true and R is false here. So first will be the correct answer. Right? Okay. Yes, I'll complain, Shreya sir. I'll complain to the Shreya sir that kids are not focusing on the lecture. Not even the previous year questions. I can't even see that some of you are actually answering, and I'm very happy about those kids. But some of you are not answering, right? I have taught you everything, right? Today and yesterday's and the previous lecture, we have learned everything about this, right? So here you have phenol and ethanol. They are saying, they are giving you the values here. From the values, we can see that ethanol is having more value as compared to phenol. Because of this relation, if pK is more, that means Ka is less. That means Ka of phenol is greater than ethanol. Is this true? Yes, that is true. So this statement is true. But next statement, they are saying ethanol is stronger acid. No, ethanol is not a stronger acid. Why phenol is a stronger acid? Because phenol is having carbon ion, this phenoxide ion. I drew the resonating structures. It is having 5 resonating structures. This is having no resonating structure. So that is why this, because of the resonating structure, is more acidic in nature. Hence, first is the correct answer. Right? Okay, guys. Yes, very good. Next is, wow, amazing. This question we did yesterday in the previous lecture as well, right? Your previous year question only, right? Let us see if you can answer this or not. Let us see. They are giving you, basically, they are giving you 3 things here. They are saying that you have CH3, CH2, CH2Br with NaOH in presence of an alcohol. Alcoholic base they have given you. So I told you one thing, when you have KOH or NaOH, anything you can write, in presence of alcohol or NaOH in presence of water, this will give you alkene and this will give you substitution, and they will give you alcohol. So in both the cases, what you have, in both the cases you have Br, right? So basically when you have, here also, when you have RBr or Rx, alkyl halide is converted to alkene, and here also when you have alkyl halide, that is converted to alcohol, right? So you have alkyl halides like Rx, it will be converted to ROH, right? So here what you have, here you have alcoholic NaOH. That means you will have the formation of a alkene, and that alkene should be Sedgwick rule, according to the Sedgwick rule. Now ma'am, what is this Sedgwick rule? For example, 1, 2, 3, right? So here you have CH3, CH2, CH2, Br, right? And this is, I think it was KOH or NaOH. Yeah, whatever the base was, KOH alcoholic, right? KOH or NaOH alcoholic, or they have given you C2H5OH. That is the same thing. C2H5OH is alcohol only, right? So it will form a more substituted C, and this is C. Here you can have this thing, right? This is CH2 and this is H. You will have the formation of this thing only because that is the only possibility here. Either double bond can attach here, either double bond can attach here. You will have the same thing, right? So the only possibility is this alkene. This is the only possibility. This is the only possibility. Now, next thing is they have given you acidic. This is acidic hydrolysis. This is diborane. This is hydroboration oxidation reaction. So I told you that in these two things you will have different things, right? So basically in diborane you will have anti-Markovnikov rule, and in this case you will firstly form carbocation and then you will have your answer. So answer will be right? So here if you talk about acidic hydrolysis or acidic catalyzed hydrolysis, you will have the formation of carbocation. The carbocation is this. Which carbocation will be formed? Which is more stable. This carbocation will be formed, right? And to this you will have the attachment of OH, right? If you talk about alkene here, when you talk about alkene, in presence of hydroboration oxidation, in this case, it will follow anti-Markovnikov rule. That means negative, that means OH negative will be attached to more number of hydrogens. More number of hydrogens are present here, so it will be CH3, CH, CH2, this is OH and this is H2. It will follow, you can write here, anti-Markovnikov rule. Anti-Markovnikov rule, that means negative, that is OH negative will be attached to more number of hydrogen. This is more number of hydrogen in the double bond, so OH negative will be attached here. Here don't say that Markovnikov rule is applied, just firstly make the carbocation, try to rearrange it, then attach OH negative, right? These are the 3 steps, okay? Acha, there was one more thing, that was oxymercuration, demercuration. In oxymercuration, demercuration, you apply Markovnikov rule. That means negative part to the less number of hydrogens, right? So here answer will be, what is what they are asking you? They are asking you what is B and what is C, right? B and C they are asking you. B is basically 2-propanol and that is 1-propanol. B is 2-propanol, right? And C is 1-propanol. So answer will be C is the correct answer, right? Okay. Yes. Ayush, I'll teach you no bond resonance in GOC because hyperconjugation is a concept of GOC, right? Okay, that is studied in GOC. General organic chemistry, we will talk about inductive effect, hyperconjugation, resonance, with all of these things, dancing resonance and different things, right? Rearrangement of carbocation and all of that, right? Okay. Now, next is, they're asking you bromination of phenol in solvent with low polarity such as this requires Lewis acid catalyst. The Lewis acid catalyst polarizes the bromine to generate Br negative. Now they are saying why we are adding Lewis acid to the bromination, to this concept. Bromination of phenol in solvent of low polarity such as this requires Lewis acid catalyst. Here they are saying Lewis acid catalyst polarizes bromine to Br positive. Yes, that is the only work of, because you had this Br. So what is the work of Lewis acid? Acid is a deficient species. So it will try to break this bond so that you can have Br positive and Br negative, right? So it will take out this Br negative and you will be left with Br positive. So the work of Lewis acid is to polarize the bromine to generate Br positive. So this is a false statement. This is a true statement. So answer is statement 1 is false and B is true. So third is the correct answer. Okay. 3 is the correct answer. Is that clear? Yes, guys. Is that clear? So 3 is the correct answer. Next is this question. It says that identify the compound Z in the following sequence, right? So you have chlorobenzene with NaOH. It is going to form which thing? It is going to form X. That is, it is basically Dow's process, right? It is basically Dow's process. So it is going to form OH here. So it is going to give you this thing, ONA. After reacting this with HCl, it is going to form phenol. It is going to form phenol. Now this phenol, basically what happened, this whole process is the Dow's process. This is the Dow's process. This is the Dow's process, right? They have given you Dow's process over here, right? Over here they have given you Dow's process. This chlorobenzene with NaOH if, they will give you firstly phenoxide, sodium phenoxide. After reacting in acidic medium, Na positive will be replaced by H positive. You will have phenol. Now, after reacting this with concentrated H2S of HNO3, you will have the formation of this OH here, right? Because of concentrated, this NO2 group will be attached on ortho and para position simultaneously, and hence you will have the formation of picric acid, that is A is the correct answer. Very good, very good. A is the correct answer. Next is, which one of the following reactions is not possible? Which is not possible? If you talk about this thing, OCH3 with HBr, it will give you, okay, here they are giving you Cl2 with AlCl3, it is going to produce Cl positive. NaOH at high temperature is also possible. This with this is not possible because this is HCl, right? Here it is making which thing? Wait a minute. Here it is making HBr, OCH3 with HBr. It is going to give you phenol. And here with HCl, it is going to give you Cl. Both are not possible. Toluene with HBr. This is toluene. Wait, this is anisole with HBr. Anisole with HBr. Positive Br negative. Okay. So basically this H positive is going to get replaced here. Yes, that is possible. Yes, that is possible. This is so possible. This is possible. But this phenol with HCl is not possible. Yes. So D will be the correct answer. Okay. So D will be the correct answer because here it is possible. It is CH3. This is O negative. This is H positive. This is positive negative. So this will replace to this thing and it will become phenol. But this is so definitely not possible because you have phenol, right? It is HCl. Now you are saying that this whole OH negative is replaced by this Cl. That is not possible, right? That is not possible. Okay, so answer D is the correct answer. Okay guys, next is, you have two statements. I can't believe you guys are not responding only. Yeah? There is only Dharan who is responding. So what you guys want? Should I not teach here on this platform? If you want that, then let me know. If you think that you are really good in chemistry, that you can do that yourself and you don't need any teacher to teach you, and the teacher is standing there for last 2.5 hours and you guys are not even appreciating, not even talking, right? I don't think so. This kind of treatment I deserve, right? So I will only teach here if you guys can respond. Otherwise, you guys, you will not see my face here, right? Okay. And that is a very strict warning to you guys because I have not even taken a break, right? And still, very sad to see this thing. Can't understand, ma'am. Okay. So guys, see. This is O negative, this is CH3 positive, this is H positive, this is Br negative. So this is possible, right? Because this CH3 and H positive, we can replace these things and it will form phenol here, right? It is still possible. But when you talk about this phenol here, this phenol with HCl, this is H positive, this is Cl negative, right? This is O negative, this is H positive. It's not possible only. There is, what kind of reaction they will do? What kind of reaction? This H positive can replace this H positive and become phenol again. It's not possible to replace this full OH negative and form Cl, right? It's not possible. That is why this reaction is not possible. Okay? Understood? Yes? Okay. I think even now you guys are not interested. Very disappointing, very disappointed I am by your behavior. Very disappointed. Okay, no worries. I promised you na that I'll teach you GOC and everything. I'll not. Right? I'll just complete the syllabus. What is my duty? I'll just complete the syllabus and that's it. Okay, nothing else you can expect from me, right? If you guys at least can respond, you don't even feel like you should respond, so it's okay, right? It's okay. Now, given our two statements, the statement is picric acid is 2,4,6-trinitrotoluene. No, that is not true, because trinitrotoluene is what? Toluene is this thing. 2,4,6. Trinitro means this thing. So that is definitely not picric acid. It should be OH over there, right? Phenol 2,4-disulfonic acid is treated with concentrated HNO3 to get picric acid. It is treated with HNO3 to get picric acid. Yes, this statement is true. So answer will be, because this we have seen there. So first is incorrect, but second is correct. So answer A is the correct answer, because this statement we have seen in the starting also. We have seen this reaction, that how if you have sulfonic acid, on treating it with concentrated HNO3, you can have the placement of NO2 group at the ortho and para positions, right? Okay, yes, okay. Now I can see some students, Monisha, Varshita, Shiva, Rafia, yes, right? So at least talk here, okay? Now, next thing is, this is also, yes, this is, in a Reimer-Tiemann reaction, phenol is converted to salicylic aldehyde through an intermediate. And what is that intermediate? What is that intermediate? Can you see that? This is CHO, definitely this is not the intermediate. Here you have OH, here you have CHCl2, right? This can be. Here you have OH and here you have CH3, this is definitely not. Here you have CHCl2, which is correct. Here you have O negative Na positive, this is definitely among them the correct answer, because here OH was not directly formed, right? You had ONe. After that, it will be converted to OH then after that, right? Firstly, this will be converted to CHO, then this ONa will be converted to OH. This is why mechanisms are also important for you, right? This is why mechanisms are also important for you. First is the correct answer, right? Okay, guys. Now, you have this reactant, it reacts with NaOH aqueous. NaOH aqueous means substitution reaction, and it occurs by SN1 mechanism with the formation of carbocation usually, right? Yes. If the reactant is a primary halide, then this will take place by SN2 mechanism, right? But here it is it is not a primary halide, it is a secondary halide. That is why it will take part by SN1 reaction, that is by the formation of carbocation. Now, which carbocation will be formed here? The carbocation that will be formed here is, basically I can write it on the next page as well. Wait a minute. This is cyclo, this is, then you have 1, 2, 3, 1, 2, 3. This is Cl, Cl and CH3, right? This is Cl and this is CH3. Now, as you can see this thing here, I am saying that firstly carbocation will be formed. So that means this Cl negative will eliminate, and hence you will have the formation of this thing, this carbocation. But this is a 2-degree carbocation. Can I convert it into 3-degree carbocation? Yes. By rearrangement, by hydride shift, I can convert it into this kind of carbocation, that is, hydride will shift here and it will be this kind of carbocation, right? So basically we have done rearrangement here, rearrangement of carbocation, right? After this we will have the formation of, this OH negative will be added here, and hence you will have this answer. The answer is OH negative here, right? Let me see which is correct. So first is the correct answer, right? This is the exact thing that we drew here, right? So first will become the correct answer. Okay, Students usually will get confused between this third one, right? But that is not the correct answer. First is the correct answer. So answer is this one, right? Okay, guys. Then next question is, you have identified the major product A and B respectively in the following set of series. You need to identify the major products here. So you have this CH3OH. When we are reacting this with concentrated ester SO4, now tell me what is the reagent? Reagent like concentrated ester SO4 is famous for which thing? It is famous for dehydration, right? It is a very good dehydrating agent. That means it is going to take out OH negative. It is going to take out water from here. So let me draw this structure here. You have CH3, you have OH. On reaction with a good dehydrating agent, H2SO4, it is going to take out this OH negative from here, and hence you will have the formation of this carbocation, right? Then it is going to take out hydrogen from the beta position. So now this is the alpha, this is the beta, this is the beta, this is the beta. 3 beta positions you have, right? So from which beta position hydrogen will be taken out? From that position where you have more substituted carbocation. If you talk about, 2 possibilities are there. If you talk about from this beta and this beta. Wait a minute. I'm drawing this by a pink pen. If you talk about this blue beta, if it has taken hydrogen by this blue beta, then answer will be, this is CH3, either this or either this. Both are same only. Either this. This can be the answer. If it has taken from this one, then the answer will be, from this one, the answer will be CH2 double bond. Now tell me which one is more highly substituted. This is having 1, 2, 3 substitution. 1, 2, 3. Both are same only, so you can just draw one thing here. This is having 1, 2, 3 substitution. This is having only 1, 2 substitution. So according to Sedzev, which is more highly substituted, that alkene will be formed. So this is going to be the major product. This is going to be the major product, and hence the answer will be, this one. A is this. This is A. This is not A. This is not A. Yes, this can be A. Right? Second is talking about B. Now you have CH3COCl. Now second is you have CH3COCl. Okay. The reaction is CH3OH. The reaction is with CH3COCl, right? Then you have which thing here? In presence of pyridine. So this reaction I told you, basically this is acetylation reaction, where acetylation reaction, whenever you have CH3COCl in presence of pyridine, the OH, the H of this OH group, alcoholic group, will be replaced by COCH3. This is the answer. Okay, this is the answer. Okay, yes. From the next class, I am going to take up aldehyde and ketones, but I'll see if you guys are interactive or not. Right? If I can see chats running in the chat box, then I will definitely continue, and I would love to teach you guys. Right? Okay. Now, okay, see, this is the question that you are asking. Concentrated ester SO4 means dehydration. So it will take out OH negative from here. Once it is taking out OH negative, it will have the formation of this carbocation. Now dehydration means this is alpha position, this is beta, this is beta, this is beta. From the alpha position where OH is attached, you have the elimination of OH. From the beta position, you have H elimination. That is how you have elimination of H2O. Right? So now, H will be eliminated either from this side or from this side. If H is eliminated from this side, then you will have the formation of this double bond over here. If H is eliminated from this side, then you will have the formation of this double bond, right? Either you draw this thing or you draw this thing. That is the same thing only, right? But if you have the elimination of hydrogen from this side, then H2 will be eliminated here, double bond will be shifted here, right? So, this bond will be shifted here, and hence you will have the formation of this thing. Now, which will be major? This is obeyed by Sedgwick rule, right? According to Sedgwick, more alkyl substituted. This is the double bond. Here you have 1, 2, 3 substitution. This is the double bond. Here you have only 2 substitutions. That is why this is a major product, right? If you talk about this thing, in CH3, COCl and pyridine, H is replaced by COCH3. Hence, you will have the formation of this thing, right? So, the answer will be OCOCH3 and this one. So, fourth will become the correct answer. Okay, guys, is that clear to everybody or not? Is that clear to everybody or not? Yes, guys, is that clear to you or not? Now we are left with just the ether part, right? Okay. We are left with the ether part. Let us do that. Okay, guys, let us do the ether part. I'll see how many of you actually type, because if you guys are not typing, I'm ending the class here only, right? I'll end the class. I'm very serious about it. I'm not even kidding. I'm not even kidding. Yes, ma'am, when you will when the session ends, the session will end after ethers, maybe half an hour. Yes. Okay. Now, let us talk about preparation of ethers. So now ethers are basically two types. One is simple or symmetrical, other is mixed or unsymmetrical. Ether is what? Ether is ROR is ether. If both the alkyl chains are same, that is called simple or symmetrical. If both the alkyl chains are different, that is called unsymmetrical or mixed ethers, right? When you talk about the formation of ethers, how the preparation of ether is done. So I told you in the starting, in the previous session, I told you that in the dehydration of alcohol, if you use a specific temperature from primary alcohols, there will be formation of ethers. So for primary alcohols, when an excess of alcohol is heated at 140 degree Celsius in presence of protic acid, 2 molecules of alcohol eliminate 1 molecule water to form symmetrical ether. For example, you have CH3OH and then you have CH3OH. Right, I can write it like this. We know that concentrated H2SO4 is a very good dehydrating agent, right? Two things can happen. Either it can take out the dehydration, the water, from only 1 molecule. That we did here, right? That we did in the previous question itself, that alcohol was released from, the water was released from only 1 molecule. From alpha you have OH, from beta you have hydrogen, right? But if the temperature is 140 degree for primary alcohols, what will happen? OH negative cannot take out from this side, H positive can go out from this side, and hence you will have the formation of, this will be, water will be eliminated. Here it will be negative and this positive will attach here, hence you will have the formation of OCH3, CH3. That is called ethers, right? That is called ethers, right? So this ROH with ROH, what will happen? One H and this OH will be eliminated and hence you will have the formation of this ether, right? Now, dehydration of 1 degree alcohol to form ether is a nucleophilic bimolecular substitution, right? That means SN2 substitution it is, right? The SN2 substitution means it is in one step. There is no carbocation, no carbocation. There is only transition state. There is only transition state that is formed here, right? So that means there is nothing like carbocation. So it will follow which order? 1 degree, it will follow the steric hindrance order. Now tell me students, which will have less steric hindrance, which will have more steric hindrance? Steric hindrance means too many people at one place, right? Crowdy, right? So here we know that 1 degree is less crowdy, so the reaction rate will be very fast. Then you have 2 degree, then you have 3 degree. That is why I am saying that 1 degree alcohol will give this reaction. Because 3 degree, it is very crowdy. It is very difficult to give SN2 reaction. 2 degree also it is difficult, right? 3 degree is the very difficult, right? 1 degree it can easily give this dehydration to produce ethers, right? Okay. Now the reaction goes like this. What is the mechanism? You have a base. This is an acid, right? It is take out this. This is acid. This is base. It will basically this base is going to accept the H positive and it will become one H here and one positive here. After that, what will happen? This on the next page I'll show you. Because this oxygen cannot handle a positive charge, it will take out this and let us see what will happen, right? It will basically, you will have this positive here. Now, if I am saying that it is a SN2 mechanism, right? In SN2 mechanism, there is no carbocation formation. So, I can't say that this electron will, this bond will break and the electrons will be given to this oxygen and you will have the formation of CH3, CH2 positive. No, because carbocation formation is a SN1 mechanism. We are talking about SN2 mechanism. That is transition state is formed here. So what will happen? This protonated alcohol and this simple alcohol, what will happen? These lone pairs are going to attack on this one and hence on that transition phase, the water is going to get eliminated. The electrons will be taken out here by the water and it will eliminate, right? But there will be no formation of carbocation. Simultaneously, this another alcohol will attack here and hence you will have the formation of this thing, right? Again, oxygen cannot handle a positive charge. So what it will do, it will take out this electrons, right? It will take out the electrons from this sigma bond and H positive will be eliminated, right? Okay, it will take out the electrons, H positive will be eliminated and hence you will have the formation of this ether, right? Hence you will have the formation of this ether. Okay. Now, next is secondary tertiary alcohols form alkenes by E1 mechanism. This I had told you that here we have done this reaction in alcohols, right? We have done this reaction in alcohol where I have told you that from one molecule of alcohol by dehydration you will have the formation of alkenes here, right? Due to steric hindrance, nucleophilic attack of alcohol on protonated alcohol does not occur because in 2 degree and 3 degree it is not possible for the other alcohol molecule to attack on the protonated alcohol, right? Because here you have, here there is no steric hindrance. That is why this another molecule can attack here. But what if it is attached to a very big group here, a big group here, then it is difficult for this alcohol to attack here. That is why it is only given by 1 degree alcohols, right? Only by 1 degree alcohols. Now this is the one of the reaction, right? Where they are saying this is 2 degree, but with H2SO4 at the same temperature 140, it is not going to give us, the major product is going to be alkene, not ethers, right? Because this is a 2 degree and for 2 degree due to steric hindrance, it is difficult to proceed by SN 2 mechanism. So it will proceed by SN1 mechanism and it will form carbocation. And we know that carbocation 3 degree is very stable, 2 degree, then 1 degree. And this SN1 mechanism, primary alcohols will not take part, right? Primary alcohol is only possible in case of primary alcohol is only possible when you have, for example, a very, very high temperature. Only then primary alcohol can form alkenes, right? Otherwise, it is very difficult. Next is secondary, tertiary alcohol. Acha, this is the same thing only. I think it is repeated, right? Wait a minute. Okay. Now this is when you have 3 degree. This is 3 degree alcohol. Again at 140 degree temperature, it will form alkene, not ethers. Right? Dehydration of alcohol in the order tertiary. This I have told you. That is your carbocation formation. This is order of SN1 reaction. Right? Not SN2 reaction. Okay guys. Next is a very, 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 very important reaction, that is Williamson synthesis. Ethers have very less reaction. One is this dehydration of alcohols, right? Because why that is important? Because either you can have ether or you can have alkene. So primary will give you ether, right? But secondary and tertiary will give you alkene. That was the important part of dehydration of alcohols. But for Williamson synthesis, it is basically you have RX, you have RONA, alkoxide. It will give you ROR, right? And then NaX, right? Basically, this RO and this R, they will give us ether. This is a reaction. You will see, ma'am, it is a very, very simple reaction. So, what kind of questions can be asked? So, I'll tell you. So, firstly, here, it is done by heating alkyl halides, right, with sodium or potassium alkoxide. This is sodium potassium alkoxide. It's a very good method for the preparation of simple and as well as mixed ethers can be formed here. Now the condition here is this thing should be primary halide. Primary halide is preferred here, right? If you have a choice, in that case, you will prefer primary halide here, right? Okay. Now, let us see. This is the full reaction that I have told you. Now, let us see what is the mechanism, right? It is a SN2 mechanism. SN2 means no carbocation. It is a transition state will be formed. Transition state will be formed. So, let us firstly go through the mechanism. Then you will get to know that why I have told you that it should be, this halide should be a primary halide. Okay. Now let us see the mechanism. First step is your alkoxide is going to give you this anion, right? Then this anion is going to react with the alkyl cation, this alkyl halide. Wait a minute. Yes, this is with I, right? Yes. So it is going to give a very slow process. Yeah, this is with basically I, okay? This is basically with iodine what is happening, right? Now transition means the attack of this thing and the elimination of this thing. So this will be eliminated and this will attack on this carbon, and hence in the end you will have the formation of this ether, right? So this is happening via SN2 mechanism, right? Okay guys, now we are taking an example where, for example, in the question they have given you form this compound. They are asking you to form this compound. Now you can say, ma'am, we can have two things. Either you can say that, ma'am, we can have C2H5 ONA and you can have C, CH3, CH3, CH3X. I told you that alkyl halide should not be tertiary. What is the reason? Now let us go to the mechanism. Now I am saying this is the wrong way. This is not possible. Rather, this is the right way. Your alkoxide can be 1 degree, 2 degree, 3 degree, but alkyl halide cannot be 2 degree or 3 degree. It should be primary, right? Now what is the reason? The reason is this mechanism. Because students, as you can see here, this alkoxide is going to attack on the alkyl halide. So if alkyl halide is very sterically very hindered, right, then it is very difficult for the alkoxide to attack. It is very difficult because, for example, as you can see here, this is C, this is CH3, this is CH3, this is this is CH3, this is CH3, this is I. Now, when this alkoxide have to attack here, it will attack from this side. It cannot attack from this side. Why it cannot attack from this side? Because from this side only this transition will happen, no? So that is why it has to attack from this side. But because of big methyl groups here, it is very difficult for this alkoxide to attack. That is why your alkyl halide should be primary, not secondary or tertiary, right? Okay, understood? Your primary halide should be which thing? Your primary halide should be, your alkyl halide should be primary in nature. It should not be tertiary or secondary. That is why for this, we have alkyl halide should be primary, right? This is why this alkyl halide is primary and sodium salt of this can be tertiary also, right? Okay, guys. Now, next is, this method is not applicable to tertiary alkyl halide, as I have told you. The alkoxide ions are powerful nucleophiles. Based on that would bring dehydrohalogenation of the tert alkyl halides to form alkenes preferably. So what will happen? This will not be able to attack because of sterically hindered product. And then what it will form? Rather than attacking, it will itself form alkenes, right? That is why. This is the thing they are saying. Now it is not able to attack here. So instead of attacking here, instead of not attacking, I would say, instead of this thing attacking here, because this alkoxide ion is not able to attack here. Because of this thing, this alkyl halide is like, what should I do? I am getting bored. So what it will do? It will convert itself into alkenes. Why? Can you tell me the answer? Why? Because this hydrogen, right, this hydrogen will be eliminated, this bond will shift here, this Br negative will be eliminated. So basically, you will have dehydrohalogenation reaction here, right? Dehydrohalogenation reaction will take place, right? So we wanted to do Williams synthesis, but dehydrohalogenation has occurred, right? That is why it's a very, very important question, and based on this, easily they can ask you the question, right? Okay. So now, yes. Okay. Now, due to steric hindrance, second is due to steric hindrance that it is not able to attack here. This is secondly, they are saying that it is not able, this alkoxide ion will not be able to attack here. So, due to steric hindrance, secondary alkyl halide prefer to undergo elimination rather than substitution. So, again, it will also go under elimination. This H positive will go, this Br negative will go. You will have the formation of this alkene rather than this ether, right? Because of the steric hindrance, right? Now, aromatic halides cannot be used in Williamson synthesis reaction. Can you tell me why? Why aromatic halides cannot be used? For example, you have this thing. Why I can't use this? Because the same thing, this CCl bond has a double bond character. Because of the electronegativity, it is very difficult to break this bond and make it react with alkoxide. That is why aromatic alkyl halides will not be used. If strong electron withdrawing group at ortho and para positions are present, then the reaction takes place. This is same as Dow's process. If at ortho and para position you have NO2, NO2 and NO2, then we know that because at ortho and para position there is negative charge in the resonating structures, it will take, this electron withdrawing group will take out the negative charge and hence the bond will get weak and hence it is possible to react. So in both the Dow's process also, here also, we are talking about the reactivity of this aromatic halide. This aromatic halide is not reactive, but it is reactive when you have at ortho and para position you have the groups. This is the reactivity. Okay guys? Yes. Yes. Very good, very good. Yes, the target is 100 likes and the target is to speak in the class, to be interactive in the class, that I can see now. Okay. Now, next thing is Next thing is phenolic ethers. Now, for example, they are asking that you have sodium phenoxide, that is your alkoxide. Now, let us check the condition. Is the alkyl halide primary? Condition check, tick. This reaction is possible, right? So, what will happen? This CH3 will replace this Na, and hence you will have the formation of this Ne-sol here. This reaction is definitely possible. That means your alkyl halides cannot be aromatic halides because CCl bond is difficult to break, right? But here you don't have to break this bond. You just have to replace this Na positive with this thing. And this bond is easy to break. Moreover, it is a primary halide. There is no steric hindrance here. So all the conditions are accurate here. That is why this reaction is possible. And this reaction is also very, very important. Phenolic ethers can also be prepared in similar way by treating sodium phenoxide with alkyl halides. Okay. Next is third reaction and your last reaction, right? Reaction with HX. Now we are doing the reactions. We have done the preparations. Two preparations we did. One is dehydration of alcohol. Other is Williamson synthesis reaction. Williamson synthesis reaction. Dehydration of alcohol only give ether when it is having primary alcohols. The condition is primary alcohols we need to have. In Williamson synthesis reaction, you need alkoxide, that is RONA, and you need alkyl halide. But in this case, the condition is this alkyl halide should be primary, and this alkyl halide cannot be aromatic in nature, right? Condition is over the alkyl halide, right? So these are the two preparation methods and a very, very important preparation methods. Now the reaction, next reaction, an important reaction is reaction with HX, right? So how it is going to react with HX? You can just simply say, ma'am, it is very easy. Ma'am, it is very easy. How it is very easy? You will say, ma'am, break this bond, right? What they have done, they have attached H over here, right? They have attached H and they have replaced R. For example, it's like this. This is negative, positive, positive, negative. Now do negative, positive, positive, negative. To this negative attach this positive, it is ROH. To this positive attach this negative, this is RX, right? Now understand one thing. Because it is a symmetrical alkene, it is very easy for me to say this. But if I give you one condition, if I say you have a bond, you have an ether, this one. Now tell me what will be the answer. Should I break this bond? Should I break this bond? That means the problem is in the unsymmetrical ethers. Symmetrical ethers are easy only. And they will ask you from the problem, not from the easy one. They will ask you from, if you have unsymmetrical ethers, how you will form alcohols from there, right? So firstly, let us see the order of reactivity. The order of reactivity is with HI, then HBr, then HCl. Reason being, what is the reason for this order? Because down the group, you have fluorine, chlorine, bromine, iodine, right? And this is how all the inorganic chemistry, especially inorganic and organic chemistry, are linked to each other. Right? If you don't know the core concepts of inorganic chemistry, it is very difficult to do organic chemistry, right? So down the group, we know that size increases, right? Size is increasing. That is why HCl, it will have this kind of bond. Then size is increasing down the group, right? That is why this bond length is also increasing. The bond length is also increasing. Hence, it is easy. If something is very large, it is easy to break that. But if something is very small, right, it is difficult to break the bond. If, for example, it is very easy to break a long stick which is having a very less thickness, but it is very difficult to break a very, very small thing like this, right? It is very difficult to break this thing, right? Okay, so hence it is easy to break this bond, but it is difficult to break this bond. Hence the reactivity is HI, HB, or HCl. Now you will think, ma'am, why HF is not included? Because HF is very explosive. The reaction is very explosive. That is why you will rarely see HF reactions, right? Okay. Now, next is the reactions. You have alkyl aryl ethers are cleaved at alkyl oxygen. Now, for example, you have this reaction. They are saying you have the choice of breaking this bond or this bond, right? We will not choose this thing. We will choose this thing. Why? Because Here you have a double bond character. We know that in phenoxide, this is having a double bond character, carbon and oxygen. I have drawn the structures of phenoxide ions also, resonating structures. So because of this double bond, it is difficult to break this bond. It is easy to break this bond. So this bond will break, and hence you will have the formation of phenol, and to this you will have the attachment of this X, that is Rx, right? And hence the answer is phenol and Rx, right? Now let us see the mechanism here, right? The mechanism goes like SN2. Let us see this, right? What will happen here? So you have ether, right? You have HI. SN2 mechanism means we are saying that it is occurring through transition state, right? It is occurring through transition state. There is no formation of carbocation here, right? There is no formation of carbocation. This is rich in electrons. This is like I am HI. What I want to do, I am an acid. I am acidic in nature. I want to lose H positive. So it will donate H positive and it will attach here. Oxygen with one positive is not very stable. So what will happen in the next step? This oxygen with H positive, this basically this positive is on oxygen, okay? This positive is on oxygen. So I'll draw it like this. This oxygen is having this positive. Now transition will happen. This nucleophile is going to attach here, attack here, right? And hence you will have the elimination of this thing. Simultaneously this will happen, right? So by the time this I is attacking on this CH3, it is making a bond. It's like the cheaters. It's for basically the cheaters, right? So you can see that SN2 reaction is a cheater. Why it is a cheater? Because in SN2 reaction you have not, there is no breakup, right? It is like there is also this person involved, there is also this person involved. It is breaking the bond here simultaneously, it is forming the bond here, right? Simultaneously things are happening. That is happening in today's world, right? But SN1 reaction, it is a very loyal reaction. It is like firstly, I will say I will break up with one person, then only I will make bond with other one, right? But in this case, nothing, no loyalty, right? It will break the bond and it will make the bond simultaneously, right? So there is not even a percentage of loyalty here, right? So it is making a bond, it is breaking a bond, and after that definitely the one who have entered, right? The one who have entered, because of which this oxygen has cheated on the CH2, CH3, it will make a bond in the end with this one. You will have the formation of CH3I and CH3CH2OH, right? CH3CH2OH, right guys? So that is the mechanism. Now important thing here. Cleavage of mixed ether with two different alkyl groups depends on the nature of the alkyl groups, right? Which cleavage will be done. We have seen the mechanism, that transition state mechanism is occurring. Now let us see how the cleavage will occur. When primary or secondary alkyl groups are present, it is lower alkyl group that forms alkyl iodide, right? Lower alkyl group that will form the alkyl iodide when primary and secondary is involved. Because primary and secondary will do, the mechanism will be SN2. Okay, for primary and secondary alkyl groups, right? For example, you have, this is O, this is CH3, and this is CH, this is CH3. So wait a minute, and this is C, this is CH3, this is CH3, this is CH. So here this one is primary, here this one is a primary group, this one is a secondary group. So these will take part via SN2 mechanism, right? That means they take part via transition state. This is the mechanism. This is the mechanism in this case. when you have primary and secondary. So in this case, the one which is lower, it will form the alkyl halide, right? It will form the alkyl halide. Okay, but this is the example. They have given you the example here. When HI is in excess, wait a minute. They have given this, wait a minute. CH3, CH2, this is alcohol with HI. Why they have given alcohol with H? Okay, this is we will see after some time. Wait a minute, right? This we will see after some time. Second thing is that we will see, don't worry. Second thing is, when one of the alkyl group is tertiary, two things we did. If your alkyl group is primary or secondary, it will take part via SN1 mechanism. If SN2 mechanism. If your alkyl group is tertiary, it will take part via SN1 mechanism, that is carbocation. And because of this, the halide formed is tertiary halide, because in carbocation 3 degree, 2 degree and then 1 degree is more stable, right? That is, this is the case. This is the case in case of tertiary alkyl halide. I will give you some examples here, right? For example, in this case, I am saying that this is my SN1, this is basically my SN1 mechanism where you have the formation of this carbocation, right? Firstly, any of the bond will break, right? So what will happen? For example, no, protonation will happen. Then this bond is going to break, right? Then you will have the formation of this R positive here, right? Now I will summarize this thing for you. I know you guys are like, ma'am, we are totally lost here. Two things. If alkyl halide is primary or secondary, if it is tertiary. If it is primary or secondary, we know that it will take part via SN2 mechanism. Here it will take part via SN1 mechanism, right? In SN2 mechanism, we know that what will happen? The answer will be lower alkyl halide. Lower alkyl halide will be formed. In this case, tertiary alkyl halide will be formed. Tertiary alkyl halide will be formed. Okay, tertiary alkyl halide will be formed. Now I will give you one reaction. Okay, one is O, CH2, CH3, and this is CH3. Other is O, CH, CH3, CH3, this is CH2, CH3, right? Other is, you have O, C, CH3, 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 this is CH2, CH3. These are the three. I think by these three examples, you will be able to answer all the questions related to this. So this is first one, this is second. Here I told you, first you need to check whether your alkyl halides are primary or whether your alkyl part is primary or secondary. This is primary. This is definitely primary. So both are primary. That means the lower one will form alkyl halide. So this will be CH3X. We have added HX here. CH3X with CH3, CH2, OH. This will be formed, right? Lower will form the alkyl halide. Here you have one is primary, other is secondary because this carbon is connected to two carbons. So it is secondary. Again you added HX here. Lower will form the alkyl halide. That means you will have CH3, CH2X plus you will have CH, CH3, CH3. This is OH. Okay, understood? Now, next is one is primary, other is tertiary. And they are saying if any of it is tertiary, then your alkyl halide will be definitely tertiary. Right? So it will be CH3, CH3, CH3. This is X plus CH3, CH2, OH is your alcohol. This bond will break, that means. Here which bond? Here this bond will break. Here this bond will break. Understood, guys? Right? Okay. Now, okay. Yes. So I think that was about the mechanism. Wait a minute. Yeah. So then you have anisole. If you talk about anisole with HI, now it is very easy to break this bond. That is why you will have the formation of phenol and methyl iodide. Right? Okay. Now let us see the carbon of phenyl group. The carbon of phenyl group sp2 hybridized, and there is a partial double bond character. Therefore, attack of I negative breaks OCH3 bond to form CH3. Basically, they are giving you this thing, that why this bond we cannot break. Because if you break this bond, you have, this is having a partial double bond character. It is why it is difficult to break this bond. That is why we will break this bond here. Right? Okay. Now we will do some electrophilic substitution reaction of anisole. It is same. You just need to remember one thing, that this is anisole. Anisole has same resonating structures as phenol. Right? Okay. So it is also electron. It is also showing plus M effect. That is why it is ortho-para directing. As you can see, you have negative charge on the ortho and para position. That is why towards electrophilic substitution is ortho-para directing, and hence in all the cases what will happen, you will have substitution at ortho and para position. You have Br2 in ethanoic acid, ortho and para is substituted where para is the major product because there is no hydrogen bonding. Next is, this so we have done. Next is with anisole in H2SO4 and HNO3. Here the electrophile will be NO2 positive because it is a nitrating mixture. Then ortho and para will be substituted. Here also para will be major because here there is no hydrogen bonding. No hydrogen bonding. Hydrogen bonding is present in ortho-nitrophenol, not anisole. Here there is no hydrogen which is connected to the electronegative atom directly. This hydrogen is not connected to oxygen here. The hydrogen of the hydrogen bonding should also be connected to the electronegative element. Right? Next is students, these are the same things, okay? Here they are just telling you how to generate. This is the same thing we have done so many times in hydrocarbons as well, right? The same thing they are telling you how to generate the electrophile here, right? Okay. Next is Friedel-Crafts acylation reaction. In Friedel-Crafts acylation reaction, let us, wait a minute, where is Friedel-Crafts alkylation? This, so they have told you that how to generate this NO2. This we have done before also when we were doing the reaction of phenol, right? Next is Friedel-Crafts alkylation reaction. So in alkylation, you have AlCl3 and you have Rx. From there, you will have the formation of R positive. Then here you will also have the rearrangement of carbocation. Here you will also have the rearrangement of R positive, if possible. Then this will attack on OCH3 and hence you will have the formation of ortho and para substituted products, right? You will have the formation of ortho and para substitution products. Now, if you talk about Friedel-Crafts acylation, this is basically when you have CH3COCl in anhydrous AlCl3. If you have CH3COCl in presence of pyridine, in that case, that OH, that H of the phenol will be converted to COCH3. But if you have CH3COCl in presence of anhydrous AlCl3, then this CH3CO, this will become your electrophile, right? It will attack on the ortho or para position. Again, para being the major product here, right? Next is some questions here, and then I think, yes, one question only we have. Let us see. You have C5H5 with X. It is going to give you C2H5, OC2H5 with AgI. What is that X? Okay, what is that X? So basically, I think I have not taught you this reaction. That is why I have taken up in the question form, right? So here you will have Ag twice O, right? On reaction of C2H5 this with Ag twice O, right? What will happen? You will have the formation of this ether here. This is also another method of formation of symmetrical ethers, right? Only symmetrical ethers we are talking about, right? So answer is B is the correct answer. Okay, guys. Okay, so I think that's it for today. There was one more question that I think was somewhere here. Was there any question that we have skipped? First, second, I think this one. Yes. Major products formed in the following reaction is a mixture of. Major products formed. Yes. Target 100 likes. Let me see how many likes I can see in the chat box. In here. 72. Very good. So now, let us see after how much time you will be able to complete 100 likes. Okay, I have to completed my target. I have, without even a single break for even 1 minute, I am standing here for last, how many hours? 3.5 hours, right? So without even a single break, right? With a lot of sweat, right? I am standing here, right? And I have taught you previous year question. I have taught you complicated questions as well. Nothing I have skipped from this lecture, from this chapter. Everything I have taught you, right? So now let us see if you are able to answer this or not. So now here you have the reaction of this with HI. One of them is 3 degree, right? And other is definitely, this is connected to 2 carbon, it is 2 degree. This carbon which is connected to this oxygen is further connected to 2 carbons. So your alkyl halide must be tertiary, right? If one of them is 3 degree, so alkyl halide must be tertiary. This is possible. In other cases, there is no possibility. So, 4th is the correct answer, right? 4th is the correct answer, that your 3 degree, if you have 3 degree on either parts of your alkyl chain, then the answer will be 3 degree alkyl halide is the halide. Okay, 3 degree is the alkyl halide. Okay, and other will be your here you will break this bond and there will be attachment of H and you will have, this is not phenol. Okay, this is not phenol, right? This is simple cyclic chain, right? There is no double bond here, right? So don't just on very hurry you will say, yes ma'am, phenol. No, it's not phenol. Okay, understood? Yes, everybody in the chat box, everybody, I hope so that you understood everything, and if there is anything, any appreciation that you have, then yes, you can write it down in the comment section as well. And I'll be starting aldehyde ketones and carboxylic acid, and the PDF will be provided to you on your Telegram channel. I'll just upload it after the class. Now, if you have any questions, if you have any like if you are like, ma'am, yes, I want to, like, I just want to know that what are the chapters that you want me to complete here, because I am prioritizing on those chapters that are not, that we have not done on this channel, right? So I'll be starting with aldehyde ketones and carboxylic acid, haloalkanes and haloarenes. So many students told that it is already done on the channel, but after we have done, like our syllabus is complete, I'll surely pick up GOC as well, right? But for that, I need one thing from you. And what is that thing? Right? If a teacher is standing here, that teacher needs at least one thing, right? Nothing like I am beautiful or not. I have nothing to do with I am beautiful or not, right? That has nothing to do with my teaching. I would love to see comments on how you like my teaching. How do you like the way I am also including previous year question along with some question related to your previous year questions, right? Or not, right? And I would like that all of you, today I felt very sad that in between there was very less students, very few students who were taking part and communicating with me in the chat box. They were communicating either with themselves, with each other, right? Or they were just not talking anything, right? So it is very difficult for the teacher to stand here and talk, right? because you feel like you are teaching to the walls, right? I don't want to have that feeling. I could have just, then so I will just post recordings. No, if you don't want to talk, then I will post recordings only. Why I am here live? So that you can ask your doubts, so that you can ask that, ma'am, this is where, ma'am, I am not able to understand. This is a step. Can you please repeat that? Right? That is why I am taking the live sessions here. Right? I don't want this camera to be a wall between both of us. Right? I want you guys to feel that yes, ma'am is there in the class only, but that is only possible if you start interacting here. You can see my NEET classes, you can see my other classes as well. Students, when they interact, my energy is on next level. When you guys will not interact, I will also get bored. Right? Okay? Then the level of the class, it will be something like very monotonous. I don't want to make classes like that, right? So be active and have some energy, right? Practice the question. If you have any doubts, you can ask me in the comment section as well. You can ask me on Vedantu JEE English comment section as well, right? But practice, right? Practice will lead you to success, right? Just watching the lecture, no. I have taken up ample of questions, but what you need to do next is you need to practice and ask me whether you have any doubts what we have done in previous 2 lectures, right? Okay guys, then bye bye everybody, take care, see you all in the next session where we are going to start aldehyde ketones and carboxylic acid. Till then, keep smiling and keep spreading the love, and also share this session among your JEE aspirants.